Hello. Uh, we are coming back from a lunch break now. We're turning from the presentation by Wild Earth Guardians to a presentation by the Oil Conservation Division. Do you have any matters to take up before we turn to Mr. Tremaine and Mr. Powell, Drs. Martin and Sandow? No? All right. Mr. Tremaine. Oh, sorry. I meant to say that immediately upon taking the lunch break, I did ask the parties, based on some of the input I got from the commissioners, if they would introduce their witnesses and just get approximately a 3-minute summary from them before we launch into cross-examination. So, Mr. Tremaine.
Thank you, Madam Hearing Examiner, commissioners and parties. Since we came back into the room, I'm of course having technical difficulties getting my VPN sorted here. So I'm going to work on that to try and share exhibits as possible, but I may need the grace of a little patience there. The Oil Conservation Division calls to the stand Dr. Eric Sandow. Pardon me, Dr. Court Sandow. Yeah.
Do you swear or affirm to tell the truth?
I do.
Thank you. Mr. Tremaine.
Good afternoon, Dr. Sandow. As you know, I'm Jesse Tremaine. I am counsel for the Oil Conservation Division. Dr. Sandow, did you prepare direct testimony in this matter on behalf of the Oil Conservation Division? And is that direct testimony OCD?
That's to engage with the microphone.
Thanks. Pardon, Chair, I didn't notice that. So to reiterate, Dr. Sandow, you prepared direct testimony on behalf of the Oil Conservation Division, and is that testimony OCD exhibit number 10?
Yes, it is.
Okay. And did you also prepare curriculum vitae in preparation for this hearing?
Yes.
And is that OCD exhibit number 8?
I believe it is, yes.
In preparing your direct testimony, did you rely on any particular reference materials or sources?
Yes, as included in my report or in my report.
Okay. And those references are listed on the final 2 pages of your direct testimony, Exhibit 10?
Correct.
Okay. Is it necessary to make any changes or clarifications to that exhibit number 10, your direct testimony?
No.
Okay. Do you adopt today as your direct testimony the pre-filed exhibit 10 as true and accurate?
Yes.
Thank you. Based on feedback from the commission and in discussion with the parties, I'm going to ask you to provide a brief 3-minute or less summary of your direct testimony for the commission.
Sure. Essentially, I was brought into this project working as a contractor through Vertex and with Dr. Martin, who you're going to hear from in a little bit, to come up with a definition of PFAS. That would seem simple enough, but PFAS is a very diverse group of chemicals consisting of hundreds of thousands of different substances. So to come up with a universal description as it applies to the oil and gas industry and this particular commission was a task that's not as easy as you'd think. And we concluded from reading the reports, reading what the science community had been talking about over the last few years. This is an issue that's affected the whole scientific community of defining what a PFAS is. There's lots of articles that are discussing this and organizations that are trying to do this. We settled in on the OECD definition with a caveat. The OECD definition calls a PFAS, a chemical with one carbon or a C3, a methyl carbon fully fluorinated, or an ethyl carbon fully fluorinated. And that's a very broad description that covers tens of thousands, if not 100,000 different chemicals. So it's a very broad definition. And we settled on that to be clear. If we could have further refined it to be more specific, but we thought it would be best to keep it general, to be consistent with the general scientific community and what they're calling a PFAS, with the limitation being the analytical methods that are used to measure. So you can see at the end of the description, we say as described in EPA methodologies, and the methods are listed there, 1633 and such, which will limit the PFAS being monitored to about 40 to 70 different chemicals.
Madam Hearing Examiner, pursuant to OCD's noticed rebuttal testimony, I do have a number of other questions that I'd like to ask Dr. Sandow now.
That's fine.
Okay. Dr. Sandow, so in your testimony just now, or in your summary, I believe that you indicated a specific number of PFAS chemicals that would qualify under OCD's proposed definition. So I want to back up to questions about PFAS generally. Given the existing OECD definition, absent the limitations in terms of the methodologies that OCD and yourself have proposed for the definition, approximately how many chemical compounds would qualify under that definition as PFAS?
That is described in the OECD document that first described that definition, and it was about 5,000.
Okay. And once you apply the specific methodologies that are proposed in the definition, approximately how many chemical compounds would qualify under that definition?
Depending on which method is used, 40 to 70. There are analytical labs out there right now that'll measure 70, all 70 of the chemicals that are listed in those three methods in a single analysis of a sample.
And of the total body of PFAS chemicals that fall under the OECD definition, how many are known to have industrial or practical use in your experience?
And again, that's listed in the OECD document where they were describing all the different PFAS that could be out there. When they did their market research to figure out what chemicals were actually relevant, it was less than 300 were industrially used or commercially used in the world.
And at a high level, could you explain for the commission the different types of PFAS compounds that exist?
The different types, different methods for measuring, or the different types?
I'm looking at a summary of PFAS generally, like surfactants, et cetera.
Oh, right. Yeah. Again, PFAS is a arching term that covers so many chemicals, and that can be scary when we talk about 100,000 chemicals that are out there that are PFAS. They range in chemical structure. So I'm a chemist, so I'll talk about chemistry. There's small PFASs, very small. They're gaseous. That's because they're such small sizes, they're prone to be in the air. There's other PFASs that have surfactant properties. They act like soaps, lubricants. These have some common uses and they're some of the most studied. So they'd be liquids at room temperature. Then there's some molecules that are so large that they're actually solids or waxes. And this diversity in chemical structure causes PFASs to be span all those different types of phases, and that impacts how they move in the environment. That impacts their toxicology. That impacts how we measure them. So when we talk about PFASs and group them under a name, just remember that we're grouping a very large class of chemicals with varying physical chemical properties that make when you talk about them as a group, they may have something common, but they differ in how they act in the environment and in toxicology.
And is it true, Dr. Sandow, that all of those types or categories of PFAS that you just described fit within the OECD definition?
Yes, they do.
And at the time that the OECD definition was developed, were there any recommendations as to its use or application by the developers? I'm asking, for instance, in application to NOCC rulemaking.
Again, in that OECD document, it's a publicly available document. The authors discussed why they were naming the chemicals and why they were trying to come up with this unified nomenclature for scientists and the public to understand. And they recognized that generic description that we're talking about as PFAS that I described earlier does cover many, many chemicals, too many chemicals, and some that are quite irrelevant to a lot of industries. And they actually suggest in that document that specific work groups or concerned areas where they are worried about PFAS should maybe think about limiting that description down to just the relevant chemicals. So even that group knew the shortcomings of naming PFAS and calling it what it is and including that many chemicals would be problematic for certain industries and be too big and too broad.
Thank you, Dr. Sandow. I'd like to ask you a couple questions about methodologies. We've heard some testimony and questions over the course of this hearing regarding OCD's proposal to include detection and screening methodologies within the definition of PFAS. Could you please summarize for the Commission the current state of PFAS detection and quantification methodologies?
Sure. We have a big group of chemicals with different physical chemical properties, and so there's different analytical methods that are used to measure those. And I'm going to break it down into sort of three main groups. The first is what I'd call screening. So there are measurements that we do to screen for organic fluorine. It's called a total organic fluorine measurement. That you take an environmental sample and you measure the total amount of organic fluorine. That's available in routine laboratories. What that provides you is a number, but it doesn't give you any idea of what's there. Doesn't give you the number of constituents, what they are. You don't get that. You just get the total amount of organic fluorine. The second type of measurement would be what we call targeted analysis. So this is where they've developed methodologies that are specifically designed to measure those chemicals down to very low levels, parts per trillion. This is unheard of. 30 years ago, when I started my analytical chemistry career, to measure the parts per trillion was unheard of. And now we're regulating to those levels, just to give you an idea of how far we've come and how low we can go. Those methods, I think the commission was talking about it, about forensic methods and being able to measure you need proper QA/QC, you need standards, you need to measure variability, you need to monitor the instrument performance. There's lots of stuff that goes in. You need certified laboratories to do that. So they're reliable measurements. Those are very important. They're the gold standard in environmental measurements. It allows us to rely on a number, to know the precision of that number so that it's dependable, enforceable. Those are the ones we really want, because that's the stuff that's usable and reliable for litigation or knowing if something is not. And the last one, which is a big research component in environmental studies and in my world, is non-targeted analysis. And it's sort of the holy grail. Can we measure everything in the sample? And we can look for everything in the sample. We probably can't measure everything in a sample. So we may see peaks, but once you see a peak, we don't know what it is. So now we have to identify it. So we have to figure out its molecular weight, and then we have to synthesize it and find a standard to be able to quantify it in a reliable manner. Those non-target analysis allow researchers to screen for other things in the environment. They're a good research tool, but it's hard to enforce and to use on a routine basis. They're really just a specialty tool to look for other things that might be there.
Thank you, Dr. Sandown. I think that you kind of answered part of this question, but I'm hoping you can provide a summary or a description of how such methodologies are developed.
So this comes down to the target analysis that I discussed. So when we're coming up with the definition, we limited it to those EPA methodologies. And we listed 5. We're going to reduce it to the 3 that are water-based methods. These are methods that are developed for the targeted measurement of those particular chemicals to very low levels. And as I sort of alluded to before, didn't allude to, I actually talked about it. These are where we know that these chemicals are common in the environment. They're common enough that we found them and had to synthesize a chemical standard in order to measure them accurately. So we know that they're around. They probably have all the toxicology data associated with them because they've been found in the environment. Someone's gone and dosed a rat or figured out, what kind of effects they might have and made them important enough to monitor. These analytical labs have then taken the standards and developed routine laboratory methods in their certified laboratories that allow us to measure to that precision of 10 parts per trillion. And to know that when we measure 4 or 10 parts per trillion, we know it's 4 plus or minus 1 or whatever that uncertainty is, right? These labs also have the controls mechanism, the blanks, as we're talking about. Like you need to know your blanks with something as ubiquitous as PFAS. Was it collected? Were you wearing a coat that had PFAS applied to it in the rain and water was dripping on your coat into the sample, causing it to be positive for PFAS, but it's actually because of the collection process. Vials that have Teflon liners, which is common in the laboratory industry, will add PFAS to a sample. When I worked at the Centers for Disease Control and we started to develop the methods to measure PFAS, we struggled because our whole lab had to be redone because we had Teflon everywhere. And we had to revamp the lab and buy new tubing in order to get the blanks low enough so that we could measure the chemicals that we were measuring and not the laboratory levels that were naturally present. This all goes into developing these methods at these routine labs so that we can get to that precision. 4 and 10 parts per trillion is extremely small concentrations. And so using those certified methods, those reliable methods, we can we're confident that something is present and it's present at a certain concentration, and we know what the variability in that concentration is.
Thank you, Doctor. You mentioned the air methods that were included in OCD's proposed definition, so I want to detour to that for a second. Are you referring to OTM method 45 and 50?
Yes.
Okay. And were those included in the proposed definition? What was the initial reason for including those in the proposed definition?
When we were first talking about the definitions, we were trying to sort of be all-encompassing of any analytical method that measures PFAS, and thinking that maybe we needed to consider things that might volatilize during a loss incident in the oil and gas industry. So we just wanted to make sure that we had those in there. After the fact, we realized that this is all about water, or mostly about water. So we've tried to funnel the methods to be water-based.
Okay. And given that both of those are acknowledged as air methods in your professional opinion, and given the context of the hearing, do you agree that it would be appropriate to remove those as methods from the definition?
Yeah, if we're talking about water, it's more appropriate to use those water-based methods than an air method.
Doctor, earlier I asked you to describe the number of PFAS that would fall under the OECD definition. So now moving on to the proposed definition, inclusive of the methodologies, I think you had indicated, let me ask you to clarify, how many PFAS would currently qualify under the complete OECD proposed definition?
If you picked one method, it'd be about 40. If you used all three methods, it would be up to 70. And the routine labs are capable of measuring all 70 of those chemicals in a water sample. So there are laboratories capable of doing that on a routine basis.
Okay, and thank you. Sorry for the repeat question there. As testing methodologies continue to develop, specifically the methodologies listed in OCD's proposed definition, how many PFAS chemicals will possibly fall under that definition?
I'll put on my Nostradamus hat a little bit, I guess. As PFAS as other PFAS chemicals are discovered in the environment, those routine methods will grow to encompass them. The reason why we measure 70 chemicals is because they have found relevance. They've been measured. We know that there's a source. They have some toxicology that we're interested in protecting of. That's why that list is there. So as the science continues to develop, and everybody's researching PFAS. You go to a scientific conference now, and that's all anybody talks about now. As we discover more and more of these things, if they're relevant enough, they will get incorporated into those methods and continue to grow. So I would expect that to grow upwards of 100, if not maybe more, to be part of routine methods in the future.
Okay. Doctor, in your professional opinion, are there any problems associated with defining PFAS as inclusive of chemicals which are either not detectable or not quantifiable?
Well, the problem, those are two different things. Detectable. PFAS data sets, I do a lot of forensic fingerprinting and trying to look at where sources of contaminants are coming from. And PFAS are bad data because they're so what we call sparse. You'll get one hit of this chemical in this sample, and you get one hit of this chemical in that sample, and it'll be zeros, non-detects in the middle. And then you'll measure that same location later, and that chemical's gone. So non-detect is a problem because they appear, disappear, and you can't do much about that. Quantifiable goes to how reliable is a measurement, and it goes to the blank controlling for the blanks and making sure it actually is a measurable thing, and quantifying with a certified reference standard or a synthesized standard so that we can measure to those very low levels with the accuracy and the precision that we need. And that's where it's important, I think, in being enforceable, is to be able to know what you're measuring, be confident in the number that you got from that measurement, so that if there is some procedure where you're trying to enforce something, you can rely on that number and be confident in it.
Doctor, during the course of the hearing, we've heard some concerns or conclusions drawn regarding the toxicity of PFAS based on the published groundwater levels. I'm wondering if you can provide the commission with any description as to how those the PFAS groundwater levels were described and how and what they mean.
Yeah, I guess it's just a word of caution that just because something's being regulated to 4 or 10 parts per trillion doesn't mean it's necessarily causing adverse effects at those levels. We're capable of measuring to those levels. When those levels were first proposed by EPA, the whole environmental industry was up in arms because we weren't capable of measuring that low, and we had to adapt. And the laboratory industry adapted and was able to develop methods that we could measure to that level. That doesn't mean that they have an effect. That just means that our analytical chemistry had to evolve to be able to measure at such low quantities to a reliable manner to be protective. People are scared of PFAS. So the EPA and the government organizations that are in charge that are enforcing these regulations or proposing these regulations wanted to be precautionary in developing methods that could measure to such low levels. So don't draw a direct linear relationship to a low a guideline or regulatory limit being the toxicity limit. That's just to be able to be conservative and to measure to those levels so we can be watchful in where these chemicals are in the environment.
Doctor, did you review the rebuttal testimony submitted by New Energy Economy from witness Dr. Hansen?
I did.
Okay. I think it's fair to characterize that Dr. Hansen draws a different conclusion about the proposed definition than you do. I'd like you to provide the commission with, in your professional opinion, why do you think you two doctors arrived at a different position or opinion?
I think it's coming. We're coming from different angles, and it's totally fine. It's not a right or wrong. It's I think Dr. Hansen is coming from, I want to measure as much as I possibly can in the samples, so that we can ensure that nothing gets in the environment that shouldn't be. And that's a valiant goal. I think if we had the Star Trek tricorder that could measure everything and anything and we could get a value, we would, right? But that's not available right now, currently. So I came at it a little bit more of a pragmatic approach, with the thought of, we have to regulate and enforce this. And we need to use reliable analytical chemistry methods that can do that, so that when we say someone is not abiding by the rules, we can prove it, and we have the information to do that with. And using those targeted analysis that cover the most concerning PFAS in the environment, with the most information out there, that allows us to do that. And remember that our method is not limited, because it will grow as the knowledge of PFAS in the environment grows, so that new chemicals are incorporated. So, I was coming from a little bit more pragmatic of an approach, I guess.
Thank you, Doctor. No further questions from the division.
Thank you. Mr. Rankin or Ms. Mulcahy, do you have questions?
Yes, I do. And if it's all right with you, Madam Hearing Officer, can I share my screen just so that it's easier for everybody?
Yes. Sheila, please allow screen sharing.
Thank you.
Interrupt for a second. I'm not sure that I've seen Dr. Hansen's rebuttal, the NEE.
Let's see. It would have been emailed to you, and I believe it was last week. Isn't that correct?
I don't want to speak for NEE, but I believe it was shared to the parties on November 4th.
Yeah. Correct. All right. Hold on just a moment, and I'll find it.
Right. I have it right here, Madam.
It was. So I'm going to, what? Yeah, around November 6th, maybe?
I have it, Madam Hearing Officer. It was November 4th, and if Commissioner Bloom has a question about it, I do have a copy that has no notes in it whatsoever. I'd be happy to share it with the commission. I haven't done anything to this document.
Madam Hearing Officer.
I represent that on under oath.
Can we just make copies of that for the commissioners?
Yeah. Sheila? Would it be possible to get hard copies of the Hansen rebuttal for the commissioners?
Madam Hearing Officer, would you like me to wait until the commission has those copies?
Commissioners, is that your pleasure? We can certainly stand down for about 5 minutes.
Could we please?
Yeah. All right. 5-minute break.
We have until tomorrow. Yes. Yes. I knew he was too much of a collection. Yeah, that's right. Well, you also. I did. 17 years at Scientific License. So I did it. Why? Work term. Nine.
please. All right, the commissioners have now been provided with hard copy of the NEE rebuttal packet. Please go ahead, Ms. Mulcahy.
Ms. Hearing Examiner.
Oh,
Hearing
sorry,
Examiner.
Mr. Tremaine.
If I may please interject, I apologize. In my fight with technology, I neglected to move for admission of OCD Exhibit 8, Dr. Sandow's curriculum vitae, and Exhibit 10 is direct testimony.
All right, any objections to the admission of division exhibits 8 and 10? Okay, they're admitted. Thank you. Go ahead, Ms. McCleary.
Thank you. Good afternoon, Dr. Sandow. Thank you for being with us.
Good afternoon.
Dr. Sandow, I have pulled up here on the screen, just to make things easier for us, what is OCD Exhibit 1-003, which is the definition of PFAS that the division has proposed. Is that correct?
Yes.
Okay, thank you. And I've highlighted it here in yellow, some language that I just want to ask you about, okay?
Yep.
Okay. You gave some testimony regarding analytical methods. When you were talking about analytical methods, were you talking about United States Environmental Protection Agency Standard Analytical Methods 531.7?
537.1. Yep.
I'm sorry, 537.1?
Yep.
And method 533?
Yes.
And method 8327?
Yes.
And method 1633?
Correct.
And together, these are the methods that you said can analyze for about 70 PFAS analytes. Is that correct?
That's correct.
Okay. And then here I see you have also listed OTM-45 and OTM-50. Is that correct?
Yes.
Okay. And OTM stands for other testing method. Is that correct?
I believe so. Yes.
Okay. And because it's an other testing method, this method is not an EPA standard method. Is that correct?
Yes, that's correct.
Okay. And so if a method is not standardized, could you explain what that means?
Sure. If it's not standardized, it hasn't been adopted as an official method, which likely means it hasn't gone through the validation process of becoming a standard method, which, as I sort of covered in piecemeal in prior testimony, is the way of developing a method is to have it documented. So it'll have to get written out. It'll have to have all the QA/QC procedures documented in that method that the lab shall follow. It'll have limits onto how the laboratory is allowed to rebound in those areas. So how much fluctuation they're allowed in certain things, what the limits are, what would be a pass or a fail of us accepting the data. So there's some criteria that it needs to meet. And that would all have to be sort of written out and accepted and then put through the validation process to become a validated EPA method.
And in your professional opinion, Dr. Sandow, is it important to only utilize standardized methods?
Caveat on that one. Is it important to you only? Depends. It's a made for use, right? So if we're talking about enforceability and passing in a courtroom setting, say litigation, I would much rather prefer having validated, approved methods because they've been pre-accepted. And you know that they've met a certain criteria in order to have gotten to that stage. And then we can validate the data based on how that method was described to make sure the laboratory has performed as they needed to in order to provide reliable data. So on an enforceability litigation side of things, I do want to use those standardized methods as much as possible.
Okay, thank you. That actually is a good segue into my next question. It's almost like you read my notes. Dr. Sandow, how do you enforce a regulation if you have a broad definition of PFAS? How do you enforce a regulation banning PFAS if the definition is so broad that there's no analytical method in existence that can analyze for all of the PFAS in the definition?
It's extremely difficult to enforce, and that's the problem of a broad definition, and why you want to use those reliable analytical techniques that are capable. But again, we do have analytical chemistry is highly sophisticated. We can measure to such low levels and measure lots of things. And I should caveat the word measure, we can see them. That doesn't mean it means they're there. We may not even have an identity for them. We just know there's a thing there that's present that fits the description and came through that method. So it might be related to what we're looking at. Once that's done in those non-targeted analysis, it then has to evolve into what is it? How do I figure out what that particular substance is? And you have to use high resolution mass spectrometry, and you have to get a lab to synthesize a chemical in order to quantify that substance to the degree that you need to. So you can measure stuff to see it. You can see stuff, but to measure it and rely on that measurement, that's where you need those validated methods.
Okay, thank you. And so OTM 45, that is only an air method, is that correct?
Yes.
And OTM 50 is only an air method as well, is that correct?
Yes, it's volatiles for air measurements, yes.
Okay. And you also, regarding analytical methods, the methods that are listed here that I've projected onto the screen, excluding OTM 45 and OTM 50, or including them if you'd like, do these methods analyze for PFOA?
I believe they do, yes.
Do these methods analyze for PFOS?
Yes.
Do these methods analyze for PTFE?
Yes.
Do these methods analyze for, we've been calling it FPEG, but let me say that acronym for you, Dr. Sandow. It's fluoral alcohol substituted polyethylene glycol, FPEG.
I remember the acronym and the name. Even as a chemist, I struggle to figure out which one that is.
Yeah.
It's
a lot to say.
Now, I don't know off the top of my head if that one's included.
Okay. How about PFHXS?
Yes.
How about PFBS?
Oh, this is like a trivia pursuit.
I'm sorry, I don't mean it to be.
I think that one is as well.
Okay. I only have 2 more Trivial Pursuit
Okay.
questions.
I hope I get my pie.
Yeah. How about PFNA?
Yes.
How about HPFO, the Gen X PFAS?
Yes.
Okay. And you testified, Dr. Sandow, that you reviewed the testimony and rebuttal testimony of Dr. Hansen, correct?
Yes.
Okay. And Dr. Hansen listed 6, what she called, quote, 6 well-characterized PFAS, which are 1 PFOA, 2 PFOS, PFOS, 3 PFHXS, 4 PFBS, 5 PFNA, and 6 Gen X, which, if I understand what you just stated in your Trivial Pursuit questions that I was asking you, all of those are currently analyzed for. Is that correct?
Yes.
Doctor, no more Trivial Pursuit questions. You got your pie.
Excellent.
You testified that PFAS are chemicals that have diverse properties. Is that correct?
Yes.
Okay. Does that also mean that PFAS have different toxicologies?
Absolutely.
Okay. I don't believe I have anything else. Thank you, Dr. Sandow.
You're welcome.
Thank you, Ms. Mulcahy. Mr. Maxwell, do you have questions of Dr. Sandow?
I do not have questions for Dr. Sandow. Thank you.
Thank you. Ms. Kessler, do you have questions of Dr. Sandow?
I do not. Thank you.
Thank you. Mr. Davis.
I do.
Great.
Hello, Dr. Sandow. I'm Tim Davis. I represent the petitioner Wild Earth Guardians. I wanted to ask you about page 10-0097 of your direct. And this is where you state, quote, that 256 PFAS with CAS registry numbers are commercially relevant, with other rarer PFAS and hundreds of associated compounds potentially occurring in the environment from intermediate process. Is that your testimony?
Yes.
Do you know how many of these PFAS have been researched for toxicological effects out of the 256?
I do not know.
Do you know how many PFAS have been researched outside of the 256 for toxicological effects?
I don't understand the question. Outside those 256 chemicals, have others been researched? I do not know.
Okay. Do you know out of that 256, do you know how many have been used in oil and gas operations?
I do not.
Do you know if there's any way to find out which of these have been used in New Mexico oil and gas operations, if at all?
You would have to look at the records and take measurements would be the way to find out.
So I want to touch on, I think, two parts of that answer. First, you said you would have to look at records. Are you talking about disclosures from the oil and gas industry?
Yeah, looking at, I think we've talked about those reports earlier in the day about different substances that had been looked at in oil and gas records. You can look at those and have some idea of things that might have been used. And then the best way to do it is to measure.
And so when you talk about measuring, you're talking about non-targeted testing?
You could, if you wanted to screen for everything that's there, you could try doing research and doing non-targeted testing to figure out what might be there, or targeted testing, which is kind of what was done in those reports that were talked about earlier.
So let's talk about non-targeted testing for a moment. I think you said earlier, first you said, you used the word measure, and then I think you then said identify. And I want to make sure that I understand that when you use non-targeted testing, you are identifying that something is there, some substance may be present. Is that correct?
Yes, it will be a peak, and a peak being, we make chromatograms. We do gas chromatographs or liquid chromatographs, and we see a bump there, which would represent a substance that's present.
And how would you go about identifying that substance with a chemical name? Let's say even with a CAS number. How would you do that from the blip to the identification?
It's a multi-step process. I've done it as a researcher, where you would, you find this peak of interest, you don't know what it is, you go, okay, I want to figure that out. So now you need to have a sample with that blip in it, and you want to find a high concentration sample, because the more that's there, the easier it is to use some analytical techniques to figure out what it is. So let's say you've got a sample with a large bump in it. You would, the go-to technique is to use high resolution mass spectrometry. What that does is it's the DNA makeup of the molecule. It gives us what's called a molecular formula, if you remember your chemistry classes, which will basically give us this formula that you can try to elucidate what the structure is. If you have a high enough resolution mass spectrometry instrument, you can actually define exactly what that molecular formula is. And from that, we can try to figure out what the molecule might be. Now, to conclusively identify it, you'd have to propose what that chemical identity is, and then you'd synthesize that chemical in a organic chemical lab and develop the standard, and then you'd shoot the standard and shoot your sample and say those match, therefore that is chemical X.
That sounds complicated. So in doing the non-targeted testing process, how certain can you be if you're trying to characterize a sample may contain unknown compounds that appear as blips, right? How certain can you be that once you've gone through the whole process you just explained, that you've actually characterized that sample accurately?
You went from characterizing a chemical to characterizing a sample.
Yes, let me clarify. Let's say that you run that process multiple times in order to characterize the sample. That's the question I'm asking you. How accurate is that process for characterizing multiple compounds which are unknown and then making them known to characterize the sample?
I don't know if I can still answer that question. If you're in non-targeted analysis, the goal of non-targeted analysis is to screen for stuff, and then you'd run multiple samples and see if it's common in all your samples, and then you would see how abundant it is in those samples. And you don't necessarily have to identify it to characterize it. You can say, we found this bump in 50 samples that we looked at, and out of 60, it's probably an important chemical in those 60 samples because it was found in 50 of them, right? And you could do that for all the chemicals that are in that sample. Maybe there's 5 or 6 or 20 chemicals that are common in all 50 of those samples. Now you're starting to build a pattern of chemical recognition where these unknown substances are found in multiple samples. That's characterizing a sample. You still don't know what they are, though, and you can't conclusively determine what they are. And we still don't have the capability to measure them to the accuracy that we may need.
And on that point, that means then when you say measure, you can't actually quantify through the non-targeted testing methods, right? Can you quantify a chemical through that process?
We call it semi-quantitation in analytical chemistry. It's a fuzzy number. So, it could be, say it's 50 plus or minus 50%, right? So that's all you can say when you've got that kind of semi-quantifiable numbers when you're doing these, when you're analyzing these samples. When you say semi-quantitative, it's just not to the precision and accuracy that we probably want in most circumstances.
And so then if we move to targeted testing methods, this would be a situation in which you know what you're looking for?
Yes. You would pick targets based on what you expect to find. Absolutely.
And if you find what you expect to find, you could quantify it.
Yes.
And so if you had 2 samples and you knew what was in sample A, you could run targeted testing methods to quantify the constituents of sample A.
If they were part of the routine methods and we had the standards for them, yes.
And with sample B, if you did not know what was in sample B, you would have to start with non-targeted analysis.
Not necessarily, but you could run targeted analysis to see if there are some common structures there. So you had quantitative numbers on the things that you could quantify. The non-targeted analysis just provides you extra information on what might be there.
And so let's assume sample A and sample B each contain the exact same number of components. Sample A, you used targeted testing because you knew what you were looking for. Sample B, you used a non-targeted analysis, or you used a targeted analysis and didn't know what you were looking for. Would you be more confident that you were able to identify all the compounds and quantify them in the sample A, which used a targeted analysis, or sample B, which, again, sample B is the sample where you don't know what's in it?
I think we're confusing the issue here a little bit of what's in sample A, what's in sample B. Targeted analysis provides us quantitative data on, say, the 40 things that are there, and we're only quantifying the 40 things. If there's 50 things, we're not looking at those other 10, right? So we know what's in sample A and sample B based on targeted analysis because we were measuring for those 40 things and getting numbers for those 40 things. The non-targeted analysis, all it's going to tell us is that there's 10 other things there.
And we don't know what they are.
We won't know what they are.
So if your sample, let's say that there's disclosure of what is present in a sample, would you be more confident that you could find out, you could use targeted analysis to confirm that those are in fact in that sample, or maybe not, but and also quantify what you do find?
No, and I'll caveat that. So the situation that I think you're presenting here is, say there's a disclosure and there's a new chemical that's not in the 40 that we're measuring, and it's disclosed as being used. And then we run samples where that chemical could be present. And we find an unknown peak that happens to be there. And we get a mass spectrometry of that thing, and the molecular weight happens to match the known thing that was put in there. You're starting to build a case that the chemical that is disclosed is in your sample. But you still have to prove that, right? So, but you're starting to get a line of evidence that demonstrates that the thing that was disclosed is actually in your sample.
And maybe this question will follow up, will end this line of questioning, I believe, is you talked about kind of building that case. That is a easier proposition to do with disclosure of what's in the sample on the front end.
I do these chemistry things all the time. Is if we know what the source looks like, it's easier to find the source.
Thank you. And sorry it took me so long to get there. In your direct testimony, you also state that knowing how ubiquitous PFAS chemicals are, these levels reflect there is no level exposure to these contaminants without risk of health impacts.
That was there, yes.
Are you referring to the 256 commercially relevant PFAS compounds with CAS numbers here?
It's probably the ones that are routinely measured, which would be even a reduced list of that 256.
So the ones that are unsafe at any level of exposure are the ones that have been studied.
The ones that are a part of those routine methods are the most studied, are the most well-defined. We know where their uses are, and that's why they've been incorporated into those routine methods, because we find them more often.
How many PFAS compounds would fall into that category?
The ones that we know of, so the 40 to 70 that we routinely measure.
Okay. So the 40 to 70 are the ones that we have sufficient data on to determine that there's no safe level of exposure?
A bit of an overstatement. It's okay. Those 40 to 70 are the ones we routinely monitor, have had regulatory limits put on some of them. So it's the ones that are toxicologically relevant have the limits that are associated with them. Not all 40 or 70 of them have limits. They've been included in the methodology because they're still they're abundant in the environment, and we feel that we should continue to watch them. And they're incorporated in those methodologies. They may not have the regulatory limits associated with them.
But you would agree we don't actually have enough data to know that at this point?
That what?
We don't have enough data to know that they are as toxicologically problematic as the ones we do have data on?
You should ask the toxicologist on that, so they'll be more readily able to answer a question like that. Because I don't know if all 40 have all the toxicological data to make that statement.
Fair enough. Do we know if these PFAS compounds, so not a single compound, but the compounds together could create additive toxicity?
I think there's certain families of PFAS, small families, that would have similar toxicological endpoints because they're similar in structure. But not all PFAS have the same toxicological response, and not all PFAS are going to have additive toxicology.
So for those that you just stated, because they have similar properties, may create additive toxicity, are those all covered in the 40 to 70 PFAS that are detectable by EPA standard analytical methods?
I don't know for sure, but that's where the majority of the tox data is going to lie, is in those 40. They are the most common and the most well studied.
I believe your testimony was that the definition that's been proposed, and when I was prepping for this, I was calling it the Wang et al. Definition, but I understand that is the OECD definition with the caveat that you testified to in rebuttal. Is that accurate?
Yeah, Wang is a University of Zurich, and he's part of the OECD. So they wrote that as an organization, and then he wanted to put that out into the scientific literature.
My understanding of your testimony regarding that definition is that it's a definition that is limited right now by what can be tested for using EPA standard analytical methods, but it will grow as those standard analytical methods develop.
Yes, I suspect it will.
So there's nothing, let me preface this with, are you familiar with the definition that was proposed by Wild Earth Guardians in this matter?
You can remind me, but yes,
it's a definition that it defines PFAS as any compound with one fully fluorinated carbon atom. If the commission were to adopt that definition, there's nothing that by adopting that definition that would impede these standard analytical methods to continue to grow. Correct?
I don't think that definition has any impact on EPA methods.
And as the Wang et al. Definition grows due to the growth in standard analytical methods, is it possible that there will be some single fully fluorinated carbon atom compounds that are not encompassed in the 40 to 70 that will be covered by that definition, but that will later be covered by the Wang et al. Definition? I can rephrase that if you need me to.
Please.
Sure. So right now we have 40 to 70 PFAS compounds that would be covered by the Wang et al. Definition, correct?
Yes.
And there are thousands of other compounds that would fit under a single fully fluorinated carbon atom definition, correct?
Yes.
And so as the Wang et al. Definition grows with testing methods, it would start to cover some of the compounds that would be included under the Wild Earth Guardians proposed definition, correct?
It would, but you have to read the Wang definition and the rationale for why they defined it that way. It was to exclude chemicals that should not be a part of the PFAS family based on their chemistries, and so there's some rationale there on why they wanted to restrict it to being a fully chlorinated methyl or a fully chlorinated ethyl carbon, so that certain chemicals were excluded and certain chemicals were included in the definition as it was stated previously, which was 2 carbons in a row that had to be fully fluorinated, right? So you have to read the Wang and the OECD rationale on why they went with that definition. The Wild Earth Guardians definition ignores that the rationale that Wang used. And what it does is it sucks in a lot of chemicals that would never be classified as a PFAS for the chemistry and the chemists that were deciding on what is a PFAS and why is it a PFAS.
The chemists who were making that decision to define PFAS in the Wang et al. The scope of the definition, that definition was not arrived upon in consideration of toxicological data, was it?
No, it's a chemistry decision.
Okay. One last topic I wanted to cover with you is something you said on rebuttal. And tell me if I don't have it in front of me. I don't have it written anywhere. So I want to make sure that I'm rephrasing this correctly to you, but that the drinking water limits in parts per trillion, I think your testimony was that we shouldn't think of that necessarily as the limit of toxicity. Is that correct?
Somewhat, yeah. Just because they're that low, don't assume that all chemicals are toxic at that level.
So when you say all chemicals, do you mean all PFAS?
Yes.
At that level?
Yeah, as we're referring to PFAS as we described them.
So the PFAS for which we do have toxicological limits in the parts per trillion, those are toxicological limits for that compound.
Again, probably a question you should ask the toxicologists that are coming up after me to define what those toxicological endpoints are and how relevant they are to the guidelines as they were derived.
Okay. I have no further questions. Thank you.
Okay, thank you, Mr. Davis. Let me turn to the chair. Mr. Chair, do you have questions of Dr. Sandow?
I do. Thank you, Doctor, for your testimony. Appreciate it. Quick question for you. I appreciated you described for us the difference between analytical screening, targeted and non-targeted. Do you know if samples that go to the EPA standards, do they start off with a analytical screening first and then go to a targeted, or do they go straight to the targeted?
Most samples that are being analyzed will go straight to targeted.
Okay.
Because it's sort of off the shelf. You can go into the store and buy them.
Sure.
Right.
Just making sure that I understood that correctly. Now, method 533, method 537.1, and method 8327 are definitely targeted analyses, correct?
Yeah, and 1633 as well.
And 1633. Sorry, I didn't go far enough to look down. My apologies. Now, the targeted analyses look for specific compounds. They're slated for specific compounds. Could there be other blips on these chromatograms as they come off of the machine, or are we just looking at 70 and that's it? There's no other blips on the chromatograms.
Depends how good your analytical lab is. There could be other blips that show up in the lab. If they're just reporting stuff and you're not looking at the chromatograms as a purchaser of that service, you won't notice the blips. The lab won't report the blips.
Okay.
If I'm doing a scrutiny of data and I see a blip and it's important to me, I could ask the lab, hey, what's that other thing that's beside the chemical that we measured? And they would probably be able to try to help me figure out what it might be. So those blips might be present, but they're likely not going to get reported in a routine setting.
Okay. Another question that kind of came up with Mr. Davis's questions. When a laboratory is looking at blips and is saying, ooh, this one was in 40 of my 50 samples, and you start figuring out what this blip was, how are you assuring after you say it's compound X, whatever X is, that when you go from just a screening to a targeted, how are you assuring that this is what we're reporting is correct? Could you kind of go into that step for us?
Sure. This happened in my thesis. I was measuring metabolites in polar bears, and there was this great big peak that was the biggest thing in the chromatogram. I was measuring all this other stuff, and the big peak was there, and I'm like, what the heck is this big thing that's there? I should probably identify it since I'm measuring this chemical mixture. And so that's what I had to do is I measured it, and it was in all the polar bear samples, and there's the biggest thing there. I'm like, okay. So I went through the process that we described. That's why I was able to describe it so nicely, because I've been through it and wrote a paper on it. Nobody's read it, though. It's a very not well-cited paper. Anyway.
There's a plug for your paper.
Yeah. So if anybody wants to read about polar bear plasma. Anyway, so you find it, it's interesting. It's in your samples. You're like, okay, as a researcher, I need to identify it. So you go to your tools that are available. And so I had to take a liter of polar bear blood and extract it and extract it down so that I could inject it on this highly specified instrument that's called a high resolution mass spectrometer. And so I needed at very high concentrations at the time, because it was a while ago. I won't age myself. And then we got a high resolution mass spectra of that substance. And that gave me the molecular formula of it. So I knew what its chemical structure was. And as a chemist, you can sort of put the building blocks together on how it fragments and what the molecular weight is to identify kind of what it is. And then I had a lab synthesize what I thought it was. And we spent money, and they spent their time, and they synthesized that chemical. And then we bought it off of them, and I injected it with the polar bear blood, and I could see that was the exact chemical. It came out, that blip came out at the exact same place where that synthesized standard came. So then I could confirm that was the chemical. Now that I've done that, I've identified it, I've given it a name, I've given it a CAS number. I can then say, okay, those 50 samples that I measured, I can go back and then quantify all of them to say the chemical is this concentration in all those samples that I ran previously.
Okay. And so that now we're on the quantification part of it. How are you doing quality assurance and quality control for that?
For that, it would have to go through the same process of in that particular instance, I'd have to re-extract those samples to make sure that they're going through the exact analytical process in order to accurately quantify that substance in it. So the QA/QC is you would make a calibration curve with that new chemical. You would extract your samples and have a recovery standard that would tell us how that you got the chemical out of your process. And then you'd run your sample with those calibration curves samples to quantify the exact amount that was found in each sample.
So is it fair to say that these methods that the EPA is using have basically followed that basic protocol to where now we have a targeted result coming out of the EPA standard?
Correct. And with the EPA methods, they go a step further. They define all the QA/QC materials you should have. You have to have this many blanks, and you have to have a lab blank, and you have to have an instrument blank, and they put all these other qualifiers in there to know that the method is valid, that the instrument's working the way you say it is. It's measuring the same thing at the same concentration over periods of time. That's all built into that as well. And then that method also defines how much wiggle it's allowed before you say, the lab's not working, let's recalibrate and run those again.
Sure. Okay. Thank you for that. Just, I apologize. When we're looking at testing, it was thrown out that 4 parts per trillion and 10 parts per trillion, or 4 nanograms per liter and 10 nanograms per liter. When we're talking about this, and I realize you said you're not a toxicologist, so I'll definitely ask the toxicologist to further on this. But does that basically mean that you're reporting at that lower level? Is that the lower limit of detection for the instrument? Yes, no, all of the above, something of that extent?
The analytical labs will all shoot to have at least a 10-fold safety margin. So if the limit is 4, they're going to have 0.4 as their detection limit so that they can quantify that number to the degree of accuracy and precision that they want. So the lab is actually able to go to 0.4.
Even further.
And they'll go even further so that again, if you're right at detection limit, sometimes you'd see it, sometimes you wouldn't, and it gets caught up in the noise. So analytical labs will always want to have that safety margin, which is usually 10. With this low, maybe 5, but they're going to have a factor of safety so that they know that when they detect 4, they know it's 4.
Okay, excellent. So with the OECD definition, kind of going with Mr. Davis's question about a single carbon that's been fluorinated, does the OECD definition encompass a single fluorinated carbon as well?
It does. I think the question needs to be flipped.
Okay.
The the definition that we've supplied is consistent with what the scientific literature considers a PFAS, and it was derived based on the OECD guidelines on chemicals that were getting screened in as PFAS that shouldn't, and chemicals that were screened out as PFAS, although they shouldn't. They should be, and so the OECD one, the European one, and well, North America is part of it too. It's not just European. That was to define chemistry-wise what a PFAS molecule is. The WEG one, it broadens it. So now it's just anything that's a fully fluorinated carbon could be in, and that sucks in millions of other chemicals that could be then classified as a PFAS, right?
Okay.
So using the OECD one limits the scope of what a PFAS chemical is to what the accepted definition is by the scientific community.
Okay, thank you. And a question had come up, and I don't remember who asked the question, about the OCD records and the testing that was potentially done in there. Were you able to review any of those records yourself?
OECD records?
No, the OCD, Oil Conservation Division.
Which records are these again?
It had come up that there was testing records that the New Mexico Oil Conservation Division had. Were you able to review any of those records yourself?
Is that part of the Jang study, or was it a different
No,
one?
sir. It's the personal records of the state.
Okay, yeah, no, I haven't
Okay.
reviewed those. No.
Okay, then I have no further questions. Thank you.
Thank you, Commissioner Bloom.
All right. Thank you, Dr. Sandow. I have one burning question. What was that substance in the polar bear blood?
It was 4-hydroxyheptachlorostyrene, which was a metabolite of octachlorostyrene. And polar bears had an innate ability to chew on octachlorostyrene and accumulate that particular metabolite.
Huh,
who knew?
Interesting. Thank
you. Now it's on the public record. I'm sure I'll get a couple more citations.
We hope so. We can only hope so. So backing out a little bit from testing regimens, at the end of the day, we're up here as OCC commissioners, regulators, administrators, and we're charged with doing a couple of things. One of which is protecting public health and the environment, and I would say perhaps another one is creating an enforcement capability. And depending on the definition, some of these things are easier than others. If our definition of PFAS is what the proponents have put forth, which hopefully I can say this correctly, it's a fully fluorinated carbon atom, correct? Okay, I'm learning. And then that would be a standard which would ban potentially thousands of PFAS or more. Is that correct?
Hundreds of thousands, if not millions.
Okay, hundreds of thousands, if not millions. So that would, and based on what we've learned about the toxicity of PFAS and how few of them have been tested, that would create a very comprehensive way to protect public health. Does that seem fair?
It would cover pretty much anything that's fully fluorinated. So that's a big blanket that's been thrown.
And then the smaller subset is is it 40 to 70 chemicals that your definition would cover?
As it's defined now by the analytical methods that are currently in practice.
Okay. and I don't know, this might be a question more suited for Mr. Powell, but why does the OCD need these two circles to be the same size? One which is protecting public health, which would be 40 to 70 chemicals, would be the only ones that we would be guarding against, and then the enforcement being the same thing. I feel like we could ban other chemicals that we can't currently enforce against, and the ban protects public health. Later, perhaps as the testing capabilities grow, which you talked about, we'd be able to enforce more of that. But at first we would protect, and then later look at growing enforcement, kind of growing that smaller circle out to match the larger one covered by the more comprehensive definition. Any reaction to that?
Well, I think there's a little nuance in the definition of PFAS is also deliberately added as well. I think that we haven't talked about that, but that's something. If PFAS is ubiquitous and it's found in water, and an oil company uses groundwater that has a PFAS that's not theirs, but they put it in the water, is that part of this, right? Like, I think that's still an important component. So other stuff not deliberately added is also part of what the plaintiffs are going for, right? The proponents are going for. So consider that as well. Most of these chemicals are scientific curiosities at best. They're not relevant. I know I think as scientists, we haven't done our job communicating clearly on PFAS and a lot of other science as well. But let's just talk about PFAS. They're scary to everybody. And when you read the internet, everything's scary and big and many. Most of these chemicals have no use. We're never going to see them. A million chemicals, there's no reason to ban a million chemicals that we don't even know what they're used for, is kind of where limiting it to things that are measurable, that are relevant, to methods that will continue to incorporate things that are measurable and relevant. You're not limiting it. You're just keeping it to a realm of that's enforceable and usable on a day-to-day basis. I think the commission has heard about disclosure. If there is a leak, there is going to be disclosure, and we are going to be able to look for other things, and they are going to be measurable. So I know that's an extreme event where we're now measuring for a release, but it doesn't preclude us from looking for other things outside those 70. So, keeping it manageable and enforceable, I think, is an important part of what this group needs to figure out how they're going to do that, and still grow with the science that's coming, and not pigeonhole it to a definition right now that limits it to 10 things or the 40 things that are in 1633.
So I think we're probably in agreement that under TSCA and other testing regimes, we've only done safety testing on a very small percentage of PFAS chemicals, correct?
Yes.
The oil and gas industry is known for being incredibly innovative. We've certainly seen that over the past, over the course of its history, and certainly the last 20 years in many ways, right? And good and bad, I suppose. Would you have any concerns that we outlaw or ban 40 or 70 chemicals, and then ones that look to be related that haven't been safety tested are suddenly in use?
With the focus on PFAS right now, if an oil and gas company is going to be innovative and use a chemical that might even look like a PFAS, I think that would be kind of silly. That doesn't mean it's going to prevent it, that's for sure. But, with the focus on it now, I can't imagine an oil company is going to want to do that. But that being said, are they using substances that might be banned in the future? I think, we live in a chemical industry that has innovation, and to think that are we going to be smart enough to include everything and protect against all substances? I don't think we can do that without some ability to enforce it. And that was the trouble of trying to work on this project, is how do you come up with a definition that is encompassing and enforceable? And that's sort of where we landed and why we sort of stuck with the definition that we provided.
All right, Dr. Sandel, thank you. No further questions.
Thank
Appreciate your time today.
Thank you. Commissioner Apomba.
I do have some few questions. I want to take it off from where my other commissioners left off. So assuming WEG, that is what of guidance definition, we are looking at over millions of components that even probably we don't know all of them as of now. Now, based on NMOCD's definition, it is about 40 to 70 components that that covers that definition. Now, then I presume that OCD's definition is going to be more or less classified as dynamic. Is that correct?
I would say responsive or dynamic. Yeah, like as the science grows and those methods expand, so will that definition of what is monitored.
And do you see that as more or less being fair to all parties involved, especially like, let's say, the oil and gas industry?
Well, I think everybody's coming from their angle, right? I think it's fair to the oil and gas industry because they know what playing field they're dealing with or what substances they have to worry about. I don't think the public's going to feel particularly happy about it because they're not going to feel protected because all the scientists have done is talked about the thousands of chemicals that are out there. So, fair depends on who you are. There's going to be an objection. It's from one of them for how we define it.
Yeah, because I do have, like, if you look at this analogy, let's say time t is equal to 0 now, we're looking at 40 to 70 compounds, right? And that is getting more and less into the intentional use and unintentional use, which I'll come to that. Now, you do have a company staying away from the 40 to 70 compounds, but they are using some other components that will more or less at time t is equal to 20, we find out that this one also belongs to the PFAS components, right? So I think there has to be a bounds on the definition. Other than that, then is the company liable at that time, t is equal to 20 or not? So that gets into intentional use and then unintentional use. So I don't know if you have any comment on that.
Well, I think the intentional use and non-intentional use is an important thing of especially to be, I guess, responsible for co-contaminants in water that you couldn't test for or don't know about. That's hard for any, like they would, it's arduous on them to be able to know what was inadvertently present, right? So I think that's not fair to the oil and gas companies or for the government organizations and enforcement to regulate something that we don't know is there. Comment on, I diverted myself there. What was the other part of the question? It was.
No, I think, so I just pointed out that at least there has to be a bounds,
Right.
With regards to the chemicals that we're dealing with. Because like, let's say if it is millions of compounds, how is even the regulator going to regulate that? Right.
I think it's a near impossible task, but remember that the chemicals we're measuring are the ones that are relevant. It's like there are thousands of scientists worldwide studying the presence of PFAS in the environment, thousands of them, non-targeted, targeted, selected analysis. The scientific community is looking for everything and anything they can find because it's relevant to society right now. We are going to discover those. For an oil company to find a secret ingredient that's never been looked at before and put it in a formulation, I think we're putting a little too much cred on oil companies finding those kind of things, right? Like literally, you're not going to be able to regulate all of them, and we have to rely on what we can measure and know that's out there. And I think that our definition allows us to grow as it grows. And yes, they are going to be, I guess, what not a question for you, because I shouldn't ask you questions, but if this method grows to 100 chemicals in 5 years, the company used it today, I think they are responsible for it.
Well, so I do have that question for NMOCD, because that goes into the intentional and then unintentional use as well. You know, because let's say our T is equal to 20, at that time, they didn't know that this was a toxic chemical, or it was not part of the 40-70 chemicals,
Right.
but they used it anyway. Who is responsible for that?
Yeah. Again, if this, and we're defining PFAS that's going to include thousands of chemicals. So that would mean that the oil and gas would have to find a chemical that doesn't get defined in that definition, that where maybe the Wild Earth Guardians one would have caught it, right?
Mhm.
And you know that's a lot of theoretical, and I that doesn't seem plausible to me. Possible, but maybe not plausible.
You know, based on your experience, can you at least guide the commissioner a little bit on the intentional and then unintentional use of, let's say, a chemical? You know, I've seen in some of the proposal from Nemoga, they want to add intentional added PFAS. And I do know NMOCD's position is not, right? So can you comment on that?
Yeah, that's a decision that needs to be made, and it is important. With the water systems having PFAS almost present in most water samples, most groundwater, I think it's 60 or 70% of groundwater samples in the US have a PFAS in them, a PFAS. River systems, probably about the same. So if you're taking surface water or groundwater as part of your industrial process, you are putting a PFAS into that process. It could be very low levels, but you're incorporating it in there, right? You've used groundwater or river water that has a monitorable amount of PFAS in it, and you're using it as a diluent, or as your base water for whatever you're doing on the oil and gas site. Was that intentionally added? Well, you intentionally added the water. You weren't adding the PFAS for any specific purpose. So now is it the oil and gas company's job to filter and treat all water before it uses it for a downhole or whatever use? Or are they able to use the water that's around them and use it in their particular application?
Yeah, I hope NMOCD is thinking about this, because I will ask that anyway. So then, are you suggesting that at least companies has to more or less test, which I know that, as part of the process, if you're going to do step-rate test or even any injection, the regulator requires to know the composition of the water that you are going to use.
Mm-hmm.
So is it more or less going to be part of it, like in terms of companies need to more or less look at the full composition of the water that they are going to use for their operations, to more or less be able to respond to whether it was intentional or unintentional?
Well, I think by keeping the analytical chemistry manageable, I think that allows them to test better, right? Like if they know they have to monitor for 70 things, maybe they will. And it becomes part of the routine of them testing for those 70 chemicals because they know that they may be liable for using them in their process. If you say it's all million chemicals that they're liable for, that makes the testing impossible. So, I think it's about being manageable and so that they're able to do what you're asking them to do. And what they're going to have to struggle with is what is background. And if you take water downstream from a firefighting foam facility, that's probably not the best water to use for your downhole injection or whatever you're using it for. If you're taking regular river water that has just background levels, maybe that's okay. But that's for the decision makers to make. But having tangible analytical chemistry that they can wrap their hands around and understand, I think is the crux of what we need to do so that we know what game we're playing.
Thank you, sir.
Thank you. Let me ask if there's any reason not to excuse Dr. Sandow at this point. No? All right. Thank you very much for your testimony,
Thank you.
Dr. Sandow. I loved it about the polar bears. That's great. All right. I think this is a good time for a break because 15 minutes brings us back at 2 hours since lunch. Then we can go to your next witness. 2:30. Maine.
Thank you. The Oil Conservation Division would call Dr. Eric Martin.
Dr. Martin, do you swear or affirm to tell the truth?
I do, yes.
Thank you.
Good afternoon, Dr. Martin. Thank you for being here. I want to start out by asking you if you have prepared a curriculum vitae to submit to the commission in preparation for this hearing.
Yes, I have.
And is that represented in OCD exhibit number 7?
Yes, it is.
And did you also prepare pre-filed written testimony? And is that represented in exhibit number 9?
Yep, that's correct.
Do you need to make any changes or clarifications to the content of that direct testimony?
No, I do not.
And today, do you affirm and adopt that direct testimony as true and accurate?
Yes, I do.
At this time, Madam Hearing Examiner, I would offer request to admit OCD exhibits 7 and 9.
Okay, let me pause a moment in the event there are objections. Exhibit 7 and 9 are admitted.
Okay. Dr. Martin, would you be so kind as to provide a brief, no longer than 3-minute summary of your pre-filed direct testimony for the commission?
Sure. Yeah, I'll be nice and quick. Essentially, I was brought in to help develop a definition for PFAS with Dr. Sandow. I was primarily involved with, just some of the kind of research that went behind that, just trying to find all the various definitions out there. There are many, many out there, as I think most of us are aware of. So yeah, I mean, ultimately, we came up with our definition that we kind of all agreed on. Dr. Sandow did have final say on what that definition was, given that he's the analytical chemist here. I was essentially, part of the team to provide any toxicological expertise that might be required with respect to PFAS. So, yeah, that's.
And in your professional opinion, I mean, did you agree with the ultimate proposal of the definition submitted and proposed by OCD?
Yes, I did.
Madam Hearing Examiner, I did have a couple rebuttal questions for Dr. Martin. We have not submitted a notice of that intent. I don't believe that that's strictly required by the rules, so I would ask to proceed with just a few, much less extensive than I had for Dr. Sandow.
All right, thank you. Go ahead.
Okay. Dr. Martin, we've heard I think quite a bit of discussion about, the chemical or chemistry definition of PFAS and discussions through some of the testimony and the questions about how those different definitions may or may not relate to the toxicity of different PFAS compounds. So I want to start with the rebuttal exhibit. Have you reviewed the rebuttal testimony from New Energy Economy submitted by Dr. Hansen?
Yes, I believe I read that this morning.
Okay. Would you agree with the statement that all PFAS are toxic?
No, that's definitely not correct. I mean, given this large, vast expanse of chemicals that we're talking about, obviously we're looking at chemicals that got majorly different kind of chemical groups, and I mean, they just don't look anything like each other. Very big differences in some of them with respect to physical chemical properties, and some of these chemicals are known to be inert. So I mean, they're certainly not all, they certainly don't all have the potential to cause toxicity.
Okay. And how would you respond to a general statement that the impacts of PFAS from a toxicological perspective are additive?
Again, given that, if we're talking about the entire PFAS universe, then I mean that statement is again, it's not correct. Again, given the vast differences in some of these chemicals, vast differences in physical chemical properties, for sure they're not going to have. If you're assuming something is additive, then you're essentially assuming that they're going to have the same mode of action. And that's just not going to be the case with these chemicals that are extremely varied. And that's not to say that a small subset, I mean, we definitely don't know the answer to this, but for sure a small subset of these chemicals could potentially have additive effects.
Okay. I think you just answered my clarifying question, which was, would you agree that certain PFAS compounds may have an additive effect?
Yeah, chemicals that are, you know, fairly similar in chemistry, again, similar phys-chem properties. It's possible that they will have additive effects.
Could you please briefly describe for the commission the general or your let me rephrase. Could you describe for the commission the typical pathway of exposure for PFAS to the general population?
Sure. Yeah, for general population, exposure would primarily be through food and water. Drinking water, obviously, could be a municipal supply, or it could be a well at someone's house or a property. We know that PFAS, it's in the food supply. So, I mean, that's where you would get most of your exposure, food and water.
Okay. I think did you hear the testimony of Ms. Troutman related to the spills and release data?
Yes, I did.
Okay. If PFAS were present in produced water and that produced water was released to surface, does that establish a cogent or potential pathway of exposure to humans?
Yes, I mean, any human that would, so I mean, obviously you're going to have some soil impacts. PFAS has the ability to migrate through soil, particularly with water, so rainwater, for instance. So anyone that's near the spill site would have, you know, potential exposure in soil. And yeah, PFAS can migrate down to the groundwater table. So they would have the ability to hit the groundwater table and then kind of pancake out from that direct, you know, depending on the direction of groundwater flow, you know, would migrate away from there. So there is some potential for people to be exposed if they had a shallow well, I suppose.
Dr. Martin, the division's proposal and red line focuses primarily on what I'll call loss of integrity events. So there's a casing failure and triggering disclosures, testing, notifications, et cetera, where completions fluid or other fluids are released and may directly travel to groundwater. Is it fair to say like that represents a clear pathway of concern from a toxicological perspective?
That if there was a failure, I mean, that would depend on where your failure occurs. If you're failing in a drinking water aquifer, then obviously that would be a concern. I mean, if there's PFAS in the product, then sure, some PFAS would be released into the water.
I mean, relative to those two examples, the different pathways that we're discussing, in your professional opinion, is it fair to say that the concern of a loss of integrity, well integrity, and contamination direct to sources of groundwater is of more significant concern than the other pathways we've described?
Sorry, you're saying like a concern to human health?
Yes, a concern. Yes, a concern to human health.
And that totally depends on the scenario, I suppose. You know, if there are humans that have, again, access to site or whatever, they could have direct contact with the soil. So there could be some exposure there. And it would be difficult to, I would actually need data to say which pathway in this particular circumstance would be kind of, more of a kind of risk to human health.
No further questions in rebuttal for Dr. Martin. The witness is available for cross.
Thank you very much. Ms. Mulcahy or Mr. Rankin?
Yes, thank you. Hi, Dr. Martin. I realized that I failed to introduce myself to Dr. Sando, so my apologies there. I'm Chris Mulcahy. I'm counsel for the New Mexico Oil and Gas Association. Thank you for being here. I just have one question, Dr. Martin. Is exposure the same thing as risk from a toxicology perspective?
No, it is not. Exposure, you're typically talking about an actual dose. If you have contact with something and that you could potentially calculate some sort of dose from it. Risk, you're talking more about kind of a probability of something occurring. So a probability of something versus an actual, exposure. Yeah, they're definitely two different things.
And are you familiar in toxicology terms, the acronym PBT?
PBT.
Persistent, bioaccumulative, and toxic?
Not off the top of my head.
Okay. I have no further questions. Thank you.
All right. Thank you. Mr. Maxwell, any questions, Dr. Martin?
I have no questions for Dr. Martin. Thank you.
Thank you. Ms. Kessler?
Not from me, Madam Hearing Examiner.
All right. Thank you. Mr. Martin, Mr. Davis.
Thank you, Madam Hearing Officer. Hello, Dr. Martin. I'm Tim Davis. I represent the petitioner Wild Earth Guardians. I wanted to ask you first, your specialty is environmental risk assessment?
That's correct, yeah.
And on page 9-0091 of your direct testimony, you talk about, I'm not sure if I'm going to pronounce this correctly, but the Gluge et al. Study, GLU within the two dots. I think that's an umlaut. GE study.
Sure. Can we put that somewhere so I can see what specifically we're talking about?
I just have a quick question about it, and I'm not sure we even need to see it. That study is the one that identified hundreds of uses for more than 1,400 individual PFAS compounds.
Okay.
And then you further state that Buck et al., that's another study, noted that 256 PFAS with chemical abstract service numbers are commercially relevant.
Mhm.
And then you go on to state that, quote, the scientific literature is making it evident that PFAS exposure can lead to adverse effects in laboratory rodents. Is that correct?
Yes. Yeah.
Can you tell us which PFAS are showing this?
The vast majority of the toxicology data out there is for our firefighting compounds, PFAS and PFOA, perfluorooctanoic acid, perfluorooctanoic acid, octane sulfonate. Anyways, PFOS, PFOA. So, sorry, can you repeat the question?
Sure. You stated that the scientific literature is making it evident that PFAS exposure can lead to adverse effects in laboratory rodents. And my question about that statement is which PFAS are showing that?
Okay. Yeah, again, that is primarily related to PFOA and PFAS. I was leafing through the ATSDR tox profile again yesterday I've looked at it many times, but it's going through it again yesterday, and its tox profile for the Agency for Toxic Substances and Disease Registry. It's kind of the go-to place for tox profiles around the world, really. And they include, it's a 2021 tox profile that includes a lot of the toxicological papers that have been presented for PFAS. And it focuses on 10 of the most relevant contaminants. And the vast majority of the tox information available is from PFOA and PFAS. So certainly PFAS and PFOA have the ability to cause toxicological effects in rodents. There's a few other individual PFAS as well that have been studied in animals and showing some of the same types of stuff like liver toxicity. But the depth of the toxicological literature for PFAS is not super impressive. Let's put it that way.
So I think you mentioned there's about 10 then of these compounds for which we have studied. 2 of those, PFOS and PFOA, are the ones that show this adverse effect in laboratory rodents.
Yeah, again, I'd have to go and take another dive to get, if you wanted a full list of PFAS compounds that have actually been studied, then we'd have to do a little bit more searching. I wouldn't just say that it's 2 right now, but not a super extensive list, but there's definitely other PFAS compounds that, have some studies for them.
Would it be fair to say that the reason that we know that they show these effects in laboratory rodents are because those are the PFAS compounds that have been studied for that purpose?
Yeah, they're the compounds that that we know the most about, the compounds that have been detected most in the environment. So they're certainly the ones that, that we, again, know the most about and most relevant as a starting point for trying to understand PFAS toxicology.
And you also state in your direct that epidemiological studies are also indicating a link between human exposure to PFAS and adverse health outcomes.
Yes.
Would those be the same PFAS compounds that are showing the adverse effects in rodents?
The same, yeah, and others as well.
And that's because those are the ones that have been studied.
Yeah, pretty much. They're the ones that we know the most about, the ones that we've encountered the most in the environment, and that's generally where you would start with, trying to figure out what's going on.
Is it fair to say that for the rest of the universe of PFAS compounds that have not been studied, we don't know what their toxicological effects might be?
That is a fair statement, yes.
And is it fair to say that for the PFAS compounds that we have studied, they generally show these negative health effects that you've talked about both in rodents and in humans?
Yes. I wouldn't want to extrapolate to other chemicals that we, again, could have very different chemistry, very different, phys-chem properties. So I wouldn't want to make an assumption that everything is toxic when, we know so little about a handful of PFAS.
And I'm not asking you to make that assumption. I guess I just want to make sure that the reason that we know that whether it's, I don't know, I think we've been talking about 2 specific PFAS compounds to maybe 10 that we have data on. The reason that we know that those handful of PFAS compounds are showing negative effects in rodents and humans is because they've actually been studied.
Yep, that's correct. Obviously, to conduct tox studies, you need people and money and labs, and there's a limiting factor with that, for sure.
There's a line in your direct that's a little bit more specific about toxicological effects that says PFAS have been further associated with causing cancer in the liver and lung. And that's from the Robarts et al. 2024 study?
Yeah, that was through, so those are associations through epidemiological studies. So there's, correlations between, concentrations found in groundwater and blood versus, various types of, two types of cancer in particular.
And my understanding is that the association between those two types of cancer and PFAS were actually about three specific compounds: PFOA, PFOS, and the Gen X. Is that
correct? Yeah, that's correct.
Those were the only three compounds that were part of that study?
I can't tell you off the top of my head.
All three of those compounds were associated with cancer in the liver and lung? All three of those compounds were associated with cancer in the liver and lung.
There was strong associations between kidney cancer and testicular cancer.
Okay. And we only know that because we have data on those three PFAS compounds.
That's correct, yes.
Moving on, you state further that most available toxicity data on PFAS focus on a few chemicals, mainly legacy compounds like PFOA and PFOS. Epidemiological studies have linked PFAS exposure to various health effects, including immune and thyroid dysfunction, liver disease, lipid and insulin dysregulation, kidney disease, reproductive issues, developmental problems, and cancer, with many findings supported by animal studies. Is that a correct statement of your testimony?
Yeah, that's correct. Animal studies have not correlated every one of those items that were listed there, but certainly there were some correlations between animal studies and the human associations.
So we have limited data on most PFAS, or even no data at all on many of them.
There's a small handful of PFAS for which we have a fair amount of toxicological data. And then there is a very large subset of PFAS for which we have literally no data.
But the ones that we do have toxicological data on just so happen to show a host of negative health effects for humans and rodents.
Is that a question?
Yes, the PFAS that we have data on, toxicological data on, those do show negative human health effects.
Yes, like the few that we have studied in depth have shown that there are toxicological effects.
You go on to state, quote, given the limited toxicity data for hundreds of PFAS in use and limited example compounds, precautionary measures may be necessary to safeguard human health based on current knowledge of PFAS impacts. Is that correct?
Yes, that's correct.
Are you referencing the precautionary principle here?
I'm not referencing it, but I'm making note of the fact that, what we're seeing with some of these PFAS is that, yes, indeed, they are, showing toxicity, and we should be concerned.
So given what we know about PFAS toxicity, would this be a situation in which the precautionary principle would be prudent to apply?
Sure, perhaps.
I believe you state in your testimony as well that California and Colorado have passed PFAS bans in some industries like oil and gas.
Yes, I believe that's correct.
Are you familiar with the law that Colorado passed?
I have not read the law that Colorado passed.
Is it your understanding of that law that it bans PFAS compounds in the oil and gas industry? Sorry, let me rephrase that question. Is it your understanding that the Colorado law bans the use of PFAS in downhole operations in the oil and gas industry?
I believe that's correct, but I can't say that for certain.
Are you aware that that law uses a definition for PFAS compounds of compounds with a single fully fluorinated carbon atom?
I'm aware that Colorado has a different definition than what we're proposing, yes.
Is it your understanding of that law that an operator has to disclose the full list of chemicals used in hydraulic fracturing fluid to regulators in the public?
I'm not aware of that because, again, I haven't read the law. So I don't know.
Okay. Are you familiar with California's law?
I have not read that law either.
Okay. I believe you stated in your testimony that contaminated drinking water is one of the most prominent pathways for human exposure to PFAS. Is that correct?
Yeah, that's correct.
Is it fair to say that in a state like California or Colorado, where a full chemical disclosure is required, that a toxicologist can do a more thorough environmental risk assessment in the case of, let's say, a produced water spill?
That might be a fair statement. If you have, I guess, a lot more information available to you, then, I mean, again, I think we've heard this a few times. Scientists always want data. So if someone gives me more data, then that would probably make me happier.
I want to ask you quickly about the drinking water standards that have been established in by the EPA for certain PFAS compounds. Are you familiar with the fact that they have been established for certain PFAS compounds?
Yes, I have reviewed that.
And some of those limits are in the parts per trillion.
That's correct. Yeah.
And I don't know if I believe you're sitting in the room when Dr. Sandow testified that parts per trillion for the drinking water standards are set for specific compounds, correct?
Yeah, that's correct.
And my question about the parts per trillion standard is who are those applicable to? And maybe I'll just go through an example. Are they is the toxicological effect on a healthy adult the same as it would be on a child?
It can be different for sure. I mean, the doses can vary based on, a number of things. I mean, if you're a child crawling on a floor that has lots of PFAS in the carpet materials, and kids tend to put their mouths and their hands in their mouths a lot more than humans or adults, you can definitely have, certain populations that are, more prone to, toxicological effects. You get different doses for different groups of people.
Would that statement also be true for the immunocompromised?
Yeah, that's possible.
The PFAS that have been regulated by the EPA for drinking water standards, those are the PFAS for which we have data sufficient to regulate. Is that an accurate statement?
Yeah, that's a fairly accurate statement.
And so then the PFAS for which we have data that's accurate and thorough enough to actually regulate, for those compounds, the EPA has set very low thresholds in the parts per trillion. Is that also correct?
Yeah, I think it's safe to say that the precautionary principle was used in development of those guidelines. Parts per trillion is, obviously extremely low concentrations that are challenging labs, and you're basically approaching background concentrations with, measuring things at parts per trillion. So,
is it fair to say that the PFAS compounds that are not regulated under the EPA's drinking water standards, for those compounds, we just don't know if they're as toxic as the ones that have been regulated?
Yeah, I mean, without studies to support whether or not they're showing toxicity or no toxicity. I mean, there's no real way of knowing. I mean, you can look at the chemical structures and try to make some inferences, but without actual studies, you're going to have a hard time making decisions on toxicity. Yes.
You were asked on rebuttal about additive toxicity. Do you recall that?
Yes.
And I believe you said you referenced the fact that we may be making. We don't have data on additive toxicity for PFAS. Is that correct?
I believe there's very little out there. I think there's a couple of papers that talk about it. I mean, from a toxicologist, it would be nice if we could have additive chemicals and take an approach like dioxins and furans, for instance. Just don't know if that's something that's plausible.
But because we don't have data, we would be assuming.
Yes, and again, given the huge variety of PFAS chemicals out there in terms of their chemistry and again, phys-chem properties, very unlikely that they're all going to add or act in an additive manner.
Is the inverse also true, that it's likely that some will act in an additive manner?
Yes, I believe so.
Mr. Tremaine also asked you about spills as a pathway. Let me be more specific about produced water spills that may contain PFAS compounds as a pathway to potential groundwater contamination. Do you recall that?
Yes. Yeah.
And I believe your testimony was that, yes, it's possible that a spill, if it contains PFAS, could first contaminate soil at the site of the spill.
Yeah. I mean, I suppose they could spill it into water as well, but a lot of spills obviously happen on land.
And so for a spill that happens on land, it could also, the PFAS compounds could migrate, for instance, through a rainwater event and find their way into the groundwater?
Yeah, that's correct.
Would you agree that the migration of the PFAS compounds in groundwater might be exacerbated in a region of karst geology?
I can't speak to that. Yeah, I'm going to leave that alone. I'll leave that to a geologist to make comments on.
All right. Thank you, Dr. Martin, for your time. I have no further questions.
Thank you, Mr. Davis. Mr. Chair, do you have questions of Dr. Martin?
Doctor, thank you for your testimony today. Appreciate it. I do just have a few questions. You started off speaking to us this morning that all PFASs aren't toxic and some are inert. Can you explain that to us, please?
Sure. Yeah. I mean, some are known to not have, toxicity associated with them. And obviously some do. And the ones that do are being studied more thoroughly. And again, it's a huge range of chemicals, and the vast majority of them have, no tox data for them. So we just, you can't say for sure that there's no toxicity associated with a chemical that you've done no studies on.
Okay. So I guess with the statement, the conundrum that we have as a commission here is that we're kind of being told that all PFASs are going to cause some type of adverse health reaction. And yet the statement also is kind of out there now that some are inert and they don't do anything. How do we clear that up for this body as we're looking at the topic of PFAS and how it's used in the oil and gas industry? In your opinion?
It is a conundrum. It's a problem. You could get into, there's programs that are, quantitative structure activity relationship type programs that You can enter chemicals in too, and it will tell you, potential toxicity based on the chemistry. It's tough. I mean, we don't even have the mode of action fully elucidated for PFOA and PFAS, the two kind of main PFAS that we have the most toxicological data for. So it's different. It's difficult to extrapolate to PFAS with no data for them. It is a conundrum.
Okay, so at least we're not alone in the conundrum. So that's the difficult part. The only other question that I had, you mentioned in your direct on page, it's OCD exhibit 9-0092, on starting with line 30, you stated that the rationale for the updated definition was to have a coherent and consistent definition across compounds from the view of the chemical structure. The new definition was intended to be easily implemented for distinguishing between PFAS and non-PFAS chemicals and easily understood by experts and non-experts alike. I understand that how that works on a chemist's side. How does that work for a toxicologist?
I mean, we weren't considering really toxicology when we were defining PFAS. So, yeah, I mean, it just wasn't considered.
Okay, so then just, and again, I want to clarify, I mentioned it earlier today, I do believe that these chemicals can be very dangerous. I don't want anybody thinking that I'm a proponent of PFAS, by no means.
No.
But, pardon? Oh, yeah, I'm not the poster child of PFAS here. But
me neither.
how does then the proposed definition from the OCD help us make sure, as was mentioned by Commissioner Bloom earlier as a question, help us not only protect, and I'm asking you in your capacity as a toxicologist, not only protect the citizens of the state of New Mexico, but also not place such an undue burden upon the oil and gas industry. Where's that middle line? How does this governing body come up with something from the standpoint of a toxicologist?
I mean, the likelihood that, there's only, I don't know, 50, 100, 150 PFAS maybe that could be used in the oil and gas industry, from what I understand. Again, the chances of having, all sorts of different PFAS in these products it's just not likely. And, if there was all sorts of PFAS out there that were at high concentrations, and again, you don't necessarily need high concentrations, we don't think. But I just don't know that, I think that we're pretty much covering ourselves with these, with the lists of 50, 60, 70 PFAS compounds that we have. That our understanding of the toxicology of PFAS is going to evolve a lot in the next 5, 10, 15 years, but we're at a point right now where we're trying to make decisions about compounds that we just don't know a lot about. And it's hard. It's hard. The likelihood that there's other PFAS chemicals out there that we're unaware of, I think, is fairly low. But again, we don't know.
Okay. So then just a subsequent question. We heard Dr. Sandow earlier state that the way that this proposed rule is submitted from the Oil Conservation Division, it is, for lack of a better term, more dynamic because it allows for growth. It allows for the ability for other PFAS compounds to be added to the list.
Yeah.
Is that a sentiment that you share as well? And as a toxicologist, do you feel that provides the assuredness, the safety for the citizens of New Mexico?
I think it's an appropriate approach given the circumstance. I mean, keep in mind that everyone is exposed to PFAS chemicals pretty much on a daily basis, and most of us are not sick. Not to say that obviously some PFAS compounds are not producing toxicity, but certainly our bodies have the ability to manage and deal with some levels of PFAS. So I think it's an appropriate manner. And again, I've been told that when there are releases and spills and stuff, that the listed compounds would have to be released to the OCD to take into consideration for for site assessment or monitoring type work. So I think it's a good approach.
Okay.
And again, the US EPA just came out with, in 2024, some, I'd say quite low numbers for groundwater. So, I mean, I think we're at a point where there's adequate health protection in place.
Excellent. Thank you, Doctor. Appreciate it. No further questions for me.
Thank you. Commissioner Bloom.
Dr. Martin, thank you for your testimony. I don't have any questions for you. Thanks.
Thank you. Commissioner Ampoma.
I do have quick ones for you. So in your testimony, I presume this one will be page 1. I know Davis tried to ask you about this question, but I did not get the clear answer on that. Line 9, the scientific literature is making it evident that PFAS exposure can lead to adverse effects in laboratory rodents. Yeah, so that one, can you be very specific with regards to what type of PFAS are you talking about here?
There is a lot of studies. I'd have to go digging again into the literature, but for sure, PFOA and PFAS again have a fair amount of toxicological data for those ones. There's quite a bit of animal studies on those two specific PFAS chemicals. There is a handful of other chemicals for which there's animal data available. Again, I would have to go look up the specific PFAS that have.
Yeah, so during the direct, you talked about, and even some of I think the chair also talked about this. You're saying that some of these PFAS are non-toxic. Now, the commission do have we do have to look at either banning the entire PFAS, so and this is probably the first time I'm hearing that some of it is not really toxic. So where do we draw the line? If you can comment on that.
Sorry, where do we draw the line with?
The ban on PFAS entirely.
It's a good question. Well, you can start with the ones that we know have, toxicity to, or associated with toxicity to humans and laboratory and animals, I think, as well. That probably wouldn't be a very long list, and some of those have pretty much already been essentially banned, like your PFAS and PFOAs of the world. You could try to come up with a list, I suppose, of PFAS that that we suspect of being toxic or having the potential for toxicity. Again, if you're using toxicological data as your basis for eliminating PFAS, then that's not going to be an extensive list. Just again, based on the available data.
So then that will more or less align with NMOCD's definition, where it's more or less limited to about 40 to 70 compounds?
Yes. You're talking about the ones for analysis that we were talking about previously? Up to 70, or I guess we were talking about?
Yeah, so I'm asking you, so we're talking about, in terms of entire ban on the PFAS, and then you're saying that we should focus on the ones that have been selected to be more toxic or more or less toxic. And I'm asking you, is it, when you say that, are you referencing to the 40 to 70 compounds that Dr. Sando,
No, I'm talking more about kind of the 10 to 15 that we might actually have sufficient data to make any inference based on, you know, any inference on whether or not they are, you know, potentially toxic.
okay, then a little bit,
Probably more like the list of 10 in kind of the ATSDR tox profile, with maybe a few others kind of thrown in there, if we're talking about toxicity data.
now, but I thought NMOCD's definition that your company supported or more or less helped, define the PFAS that we are more or less looking into banning. I thought we're looking at about 40 to 70 compounds, but now you are saying 10 to 15? It's a little bit confusing.
I'm also confused. So you're saying that I suggested that you ban 40 to 70 compounds?
Okay, so based on Dr. Sanders' testimony, he talked about NMOCD's definition that you supported, or more or less you helped drafted, includes the 40 to 70 compounds that are known to be toxic. But now you are saying it's about 10 to 15.
Okay, I would have to go back and look at that. I don't.
Okay.
I have a hard time believing there's adequate data on 40 to 70 chemicals to ban them based on, you know, their potential toxicology.
May I respond?
Yeah, I'm okay with that.
Commissioner Poma, I believe a review of the record will indicate that Dr. Sandow testified to the effect of OCD's definition will capture 40 to 70 compounds presently. His testimony was not that 40 to 70 compounds have a demonstrated toxicity for human beings. And our current Dr. Martin is testifying that there's a toxicological effect known for 10 or so. I don't want to paraphrase while he's on the stand. So these are different things. The chemical definition proposed by OCD is more expansive than the list of PFAS compounds that Dr. Martin is saying have an established connection to adverse health effects, or perhaps he can rephrase it if it needs to be corrected.
Thank you for the clarification. That helps a lot. Do you have any reference that you can share with us with regards to the non-toxic PFAS? Do you have any reference?
Not off the top of my, well, not on me right now, but I could certainly provide some feedback once I'm not sitting here.
That would be great. You know, I know a question was asked about the California and Colorado ban on PFAS. Now, you have in your direct testimony on line 17 and 20, some states have outright banned PFAS used under some circumstances or in some industries such as oil and gas. And you cited California and Colorado. So how is this one going to be different from what what NMOCD is proposing for, what NMOCD is more or less supporting?
Well, I mean, different jurisdictions can take, you know, different approaches to the same problem. It's probably unnecessary to ban every single PFAS out there, just because obviously some are, they don't have, you know, they're not suspected, or they're not toxic, or they're not expected to be toxic. So I mean, I just don't see any need to ban chemicals that, you know, for no good reason. If they're providing a purpose to the oil and gas companies, then yeah, based on again toxicological evidence, there would be no need to ban them.
Thank you. No further questions for you.
All right, thank you. Any reason not to excuse Dr. Martin? All right, thank you very much, Dr. Martin, for your testimony.
Thank you.
Mr. Tremaine.
Madam Hearing Officer, may I have 5 minutes?
Certainly, certainly. Let's take 5 minutes.
Actually, Madam Hearing Officer, can we take like a 10-minute? It is hot in here.
Okay, sure, 3:30.
Thank you.
Thank you. We just took a short break to explore temperature controls in the room. We're back with Mr. Tremaine and Mr. Powell. I see Mr. Powell on the stand. Mr. Powell, do you swear or affirm to tell the truth?
I do.
Thank you very much. Go ahead, Mr. Tremaine.
Good afternoon, Mr. Powell. Did you prepare direct testimony on behalf of the Oil Conservation Division in preparation for this hearing?
I did.
Is that included in OCD submission as Exhibit 2?
I believe so, yes.
Okay. Did you also prepare a curriculum vitae for yourself in preparation for this hearing?
I did.
Is that included as OCD Exhibit 3?
Yes.
Okay. Did you also participate in the preparation of OCD's proposed modifications to the amended application, what I'll otherwise call the red line of Wildlife Guardian's rule proposal?
I did.
And is that included in OCD's submission as OCD Exhibit number 1?
Yes.
Okay. Did you also prepare a set of slides describing OCD's proposal or proposed changes?
I did.
Is that OCD Exhibit number 4?
It is.
Okay. Did you provide examples of frac focus disclosures for the commission's information?
I did.
And did you pull those from the frac focus website yourself?
I did.
Okay. Are those listed in OCD submission as Exhibits 5 and 6?
Yes.
Okay. And did you also prepare a slide deck of rebuttal testimony describing OCD's proposed changes relative to NMOGA's red line?
I did.
Okay. And is that submitted to the commission as OCD Exhibit 11?
It is.
Okay. Do you need to make any changes or clarifications to your direct testimony today?
I don't.
Do you adopt that written direct testimony as true and accurate today?
Yes.
Okay. Are the rest of these exhibits true and accurate to the best of your knowledge?
Yes.
Okay. Madam Hearing Examiner, I would move admission of OCD Exhibits 1 through 6.
Okay, I'll pause a moment in the event there are objections.
And 11.
And 11. 1 through 6 and 11. Oh, thank you. They're admitted.
Madam Hearing Examiner, I have, I'm going to ask Mr. Powell to provide a summary of his direct testimony, an oral direct summary. And then I do have a number of rebuttal questions, as we earlier noticed. And based on the feedback of the commission, I believe it may be beneficial for Mr. Powell to work us through both slide decks. So my proposal would be to proceed in that order, if it's agreeable to the commission. So summary, my rebuttal, direct examination, and then moving through both decks.
Are there objections to that plan? No? All right. I would like to mention just one thing, Mr. Tremaine. The notice of this hearing said that we would accept public comment between 8:30 and 9 and 4:30 and 5. We're less than an hour from 4:30. And at least as of, yesterday, I did have 2 people who wanted to offer comment at 4:30. So I may break in a good point around there just to take 2 public comments.
I certainly, Madam Hearing Examiner, do not want to go any longer with Mr. Powell than we have to, but I think that by the time we get through the decks, we're going to be pushing the end of the day. So I would propose that we just plow forward, and wherever it's appropriate to stop at 4:30, we can pick up again tomorrow.
Oh, okay. All right. Thank you.
All right, Mr. Powell, after all that, will you please provide a brief summary of no more than 3 minutes for the commission of your direct testimony?
So I'll go over just shortly what I included in the direct. OCD supports action regarding the ban of PFAS as the OCD has defined. The primary goal of OCD's modifications to the proposed amendments is to ensure that changes are protective, ensure proper management of resources, which includes waste and correlative rights as to hydrocarbon resources, staffing resources as to the OCD, and ensuring efficient implementation of those changes. The division's proposed amendments seek to protect public health and the environment by limiting the exposure to PFAS to groundwater.
All right, Mr. Powell, thank you for that. I'm going to ask you a number of questions related to prior testimony. Are you familiar with, or have you heard during the course of this hearing discussion comparing OCD's proposal versus those of other states?
I have.
Okay. And are you aware of the distinction that that the comparison is being made between state statutes in other states and a proposed rule in New Mexico?
I did. I heard that with the other witnesses earlier in the week, where in both, it sounded like California and Colorado enacted legislative bans, where this proposal is looking at a regulatory ban, which are quite different.
And is that also true in the context of outside of a PFAS ban in terms of a disclosure within the context of oil and gas activities?
I would imagine so, even though I haven't written too many legislative documents. I would think the disclosure and the discussion over legislative is quite more extensive, more parties involved than a regulatory process.
And do you understand that the disclosure requirements in Colorado and California are in fact in state statute rather than rule?
Oh, I apologize. I thought you meant disclosure for the actual rulemaking. Yes, the disclosure, from what it sounds like in California and Colorado, are quite different than what it is in New Mexico.
Okay. In terms of the immediate rulemaking, Mr. Powell, will OCD receive any additional funds or staff as a result of this rulemaking if any version of it is enacted or promulgated by the commission?
No.
Does OCD currently employ any chemists, toxicologists, industrial hygienists or hygienicists that are competent to detect, quantify, or assess PFAS chemicals?
Some of our staff may have some background in some of those things, but as far as having somebody on staff for those specific things, no, we don't.
Does OCD currently have any full-time positions, even if vacant, that would fit that description?
Not looking at the extent in this hearing, just to justify what we're doing. We've had several doctors up here specific to their fields, and that's outside of the experience that OCD typically provides.
If OCD were to receive disclosures for all downhole or completions activities related to every well, would OCD have the staff to or the competency to affirmatively review the content of those chemical disclosures?
Not for all wells, no.
And for context, in the course of a given year, how many wells are we talking about?
So in our draft, and I'll get to that in the slides, we proposed just for completion and recompletion activities. In that scope, you're probably looking at 2,000 to 3,000 instances per year. If you talk about all downhole and chemical treatments, you're probably looking at tens of thousands of events per year.
So that's tens of thousands of qualifying events, but is it also true that under OCD's proposal, which we'll discuss in more detail, those disclosures are limited to incidents where there is a loss of containment?
So in OCD's proposal, it would be centered around the loss of integrity of the well itself.
Okay. And do you believe that with current staffing, competencies and availability, that OCD will be able to appropriately process that number of qualifying events triggering disclosure? Does my question make sense?
Yeah, it does. And OCD would, through a couple different avenues, internal staff, depending on the type of impact, we could always look at outside parties to help in that evaluation. We could also require operators to consult a third party toxicologist, chemist, those kind of things to ensure that that threshold is met to the OCD satisfaction.
Okay. So is the contemplated or discussed, briefly discussed disclosure related to all wells a manageable proposition for the Oil Conservation Division?
For all wells, no, it's not.
All right. Did you hear during earlier testimony, Mr. Powell, a discussion about an additional need for data and specific areas of research?
I did.
Okay. Does the Oil Conservation Division have any appropriated research budget?
We do not.
Does OCD participate in or conduct any academic research?
We do not.
Okay. Notwithstanding that, would OCD support the concept of any of the reference research that's been discussed?
We would definitely support more research. I think that's how industries move forward. The way we based our definition was based on the thought process that more research will be done, more chemicals may be added, and we wanted to make sure it encompassed those.
Does OCD have the authority to require specific investigations or data from operators? And can you very briefly explain the context that that authority might be used in relation to this rulemaking hearing and PFAS disclosures?
In this rulemaking, we're defining it in the rule itself as far as if there's a breach of integrity of the well, if something happens and we need to do more investigation, we need more disclosure. We've built that into the rule. The OCD through the Oil and Gas Act also has subpoena powers and the powers to make investigations as needed.
I have a few questions segueing to release data. Do you recall from earlier testimony there was some discussion of the number of spills, releases, and produced water volumes?
I do.
In terms of the spills data or releases, to what extent does OCD rely on operator reporting?
Most data that's in our system is operator reported. The instances where we find that it's not reported by the operator, OCD typically starts some sort of compliance action with the operator that didn't report it. And ultimately, it's the operator that ends up reporting that as well, because they're the ones with the pertinent data. OCD just verifies and validates what they're reporting to ensure it meets the threshold that OCD is looking for.
Okay. At a very high level, when an operator reports a release to the Oil Conservation Division, what do they report?
At a very high level, they report what was released, what scenario it was released. The new reporting structure builds in proximity to waterways, if water courses were impacted, if groundwater was impacted. So it builds in what was released, where it was released, and if there's any concerns with that release.
One of the categories of reporting for release data is produced water. Is that correct?
That is correct.
When an operator reports a release of produced water, what is included in quote unquote produced water?
It's a very broad category. When you're talking produced water, it's any water that is produced up the wellbore.
Are completions fluids or other additives that may be used in drilling operations part of that water that gets reported by volume as produced water?
As long as it's fluids that's gone down the well and flown back up the well. If it's completions fluids prior to injection, it would not.
If there were to be PFAS as we've defined it, in completions fluids, is it possible that PFAS is then present in the produced water at the surface?
It is possible, yes.
And are you are you able to quantify or know how OCD would attempt to quantify currently the presence of PFAS in a release?
Prior to this rulemaking or post?
Currently.
Currently, OCD doesn't have that as something that we do as a standard as far as our investigations.
And how do you see that? How do you see that working practically if, for instance, OCD's proposal was adopted by this commission?
So there would be an investigation essentially before a release was determined in the well. of the chemicals that were injected into the well, a review of those to see what potentially harmful chemicals are being used by the operator, to see what needs to be investigated. And then as part of that investigation, if there is shown to be an impact to the water, then that release would be transferred into Part 29, which is the release rule.
Okay. Is it a release if a transporter intentionally dumps produced water?
It is a release and a violation as well.
Has OCD, the Oil Conservation Division, taken any enforcement actions for such a fact pattern?
We have.
Does such a release also qualify as illegal or unpermitted dumping under other OCD rules?
It is.
And does such a release require delineation, characterization, and or remediation under Part 29?
It does.
If such a release impacted groundwater, would there be any other steps required under other sections of OCD rule?
Yeah, as far as the cleanup, it would start under Part 29, and if groundwater was discovered to be impacted, it would transition to Part 30.
I want to transition very briefly to OCD's proposed language in 19.16.17 that focuses on what I'll call loss of containment with completions or recompletions events. If there is a loss of containment and completions fluids or other fluids are exposed to groundwater, like we just talked about, what is the reporting and triggering mechanism in that fact pattern?
I can pull it up, but at a very high level, it would be an immediate notice to the division that there was a loss or potential loss of containment and potential impact. It would be a disclosure to the division what chemicals were used in the well. The OCD, the operator, potentially with the third party as well, would evaluate those chemicals for any potentially harmful chemicals. That fluid stream would be evaluated for those chemicals. And if there is a chemical of concern identified, then it would move to Part 29 and then subsequently Part 30 if groundwater is affected.
Okay. If there is a chemical of concern disclosed to the division, is it your intent to utilize the standard testing methodologies that we've been discussing to seek to detect that compound?
So in part, yes, for what we're discussing here, it would be those methods that are in the definition, but it also could include all other chemicals of concern that could be in chemicals that we didn't define. It could be chlorides. It could be those kind of DRO, GRO. We would be looking for all chemicals of concern the way that's written. But for this rulemaking, we would be primarily looking at PFAS using the methods that we proposed.
Okay. I want to talk a little bit about the disclosure discussion that we've been having over the course of the hearing. To briefly reiterate, is OCD supportive of the proposal to provide a full chemical disclosure to the public?
We are not.
OCD's position, is it true that OCD's position is that chemical disclosure should be made upon the identification of a qualifying triggering event such as a loss of containment from casing?
So to expand, that's a very deep question. So OCD is looking for a full chemical disclosure on loss of containment to the OCD for trademark chemicals, those kind of things. Because trademark chemicals are allowed to be used in New Mexico, why OCD isn't supporting the full chemical disclosure across the board is because the current authorities in the state. OCD, I don't know if it would support or not support a full chemical disclosure if it went through legislation. But as it's the regulatory state in New Mexico is currently trademark chemicals, those kind of things are protected for more than just PFAS constituents. It's wide ranging.
You beat me to my next question, which is that whether OCD supports a full chemical disclosure to OCD and under what circumstances.
So it would be to the OCD if there was a breach of containment. So if there is that risk or that potential for impact to water, that's where we would be asking for that full chemical disclosure. Because as we talked before, if we cover all downhole scenarios, you're looking at tens of thousands of downhole treatments, chemical treatments, those kind of things. Whereas OCD is looking, or if there is that potential to impact, that's where we need to actually perform that more thorough investigation other than just getting the disclosure. The disclosure is just the initial part of that thorough investigation.
I want to ask you some questions to kind of clarify OCD's proposed scope of chemical disclosures and why. In the event that OCD were to receive chemical disclosures for any qualifying treatment, whether it's completions, recompletions, as we discussed, downhole activities, I believe you just said that would constitute tens of thousands of reports.
Yeah, for downhole activities, there's tens of thousands of downhole activities that involve the injection of chemicals, whether it be corrosion inhibitor, those kind of things, H2S scavenger in the state every year. So if it incorporated all downhole activities, you would be looking at tens of thousands of instances.
And to your knowledge, is the Oil Conservation Division subject to the Inspection Public Records Act?
We are.
And if OCD were to keep tens of thousands of records in-house, each of those records could be requested by any member of the public, correct?
It could.
Okay. And the records that we're talking about are include contents that are listed as either proprietary or trade secret compounds. Is that correct?
Yes.
And to the best of your knowledge, is it true that there is an IPRA exception where the Oil Conservation Division may have to make the decision to withhold records if they're listed as proprietary or trade secret compounds?
Generally, yes, that's my understanding.
And so if that were the case, would it be such that in any such request, OCD would be tasked with assessing whether or not a disclosure, in fact, incorporated trade secret or proprietary compounds in order to make the decision whether to release the record or not?
Yes, and to expand on that a little bit further, also caveating with your previous question about adding additional staffing, those kind of things. Currently, if we were doing that with IPRAs, that would take away from staff's other time, both legal and technical, to perform those evaluations, which would take away from other activities the OCD is performing.
And if OCD were to reject a request for production of records based on inclusion of proprietary information, could OCD be subject to a deemed denial lawsuit?
I'm not a lawyer, but I would imagine so.
Could you explain the types of disclosures that we are talking about? Let's strike that. We can talk about the frac focus disclosures at some point if beneficial to the commission, but is it your understanding that to some degree the same information or general information is already available to the public through frac focus?
That's my knowledge, yes.
Okay. And what would be the difference contemplated in OCD's proposal with the level of data or specificity that would be provided in a disclosure triggered under our proposal?
The disclosure, are you talking to the OCD or the disclosure to the other entities that we've provided?
Yeah, let me rephrase. That was a compound, terrible question. So I'm trying to get at the difference between what's available on Frac Focus and what you as deputy director will get if there is, for instance, under OCD's proposal, a loss of containment impacting groundwater. So what do you propose that OCD will receive? Will it include CAS numbers? Is it other information, et cetera?
So it would include all the CAS numbers, anything that's currently marked as proprietary and Frac Focus. OCD would be looking to get that information as well as what chemicals could be there. OCD would be evaluating those CAS numbers or SDSs, those kind of things, to see if there's any chemicals of concern or anything that needs to be investigated further.
Mr. Powell, was there ever a time when OCD maintained such completions or fluids records such that are included on Frac Focus today?
Yes, OCD attempted that once.
You're intimating my next question, which is, were there any problems with that process?
Yes. Frac Focus is built to contain that information, make it public, and it's done for various states. It's a repository for various states, various governments, so it's built for that purpose. OCD's system was attempted to be built for OCD, and it was very limited, and it took substantial maintenance to try to keep up, and so that's why OCD moved to Frac Focus, is my understanding.
So is it fair to summarize that OCD would not find it beneficial or useful to maintain records where there disclosure records where there was not a known impact to water?
It would constrain considerable resources to try to move back to that proposition.
Is it also fair and reasonable to require OCD to take those necessary steps, review the information, and receive more detailed disclosures in the event of a qualifying release or loss of containment?
Absolutely.
I want to ask you a couple questions about intentional use. Are you familiar or do you recall during the course of the hearing, hearing discussions about intentional use versus unintentional use?
I am.
And that relates in this context specifically to PFAS compounds, correct?
That is correct.
Okay. Is it fair to say that there's actually two different contexts which we need to address here, being intentional use of additives versus intentional use of background or source materials?
I would maybe phrase it a little bit differently. So there's the intentional use that's being proposed by NMOGA that's very ambiguous as far as intentional use. It doesn't define who intentional is. So that could be intentional being a chemical company not providing the operator the data, so the operator certifies without having intentional knowledge because they didn't receive it. So that intentional use, the OCD does not look at the intentional, I believe that you're looking, which is the second part of what you're looking at as far as background, using municipal waters, which based on the experts could have some background PFAS in it. OCD is looking at chemical additives. They're not necessarily looking for those background items. Those background items should be typically regulated by your Department of Health through NMED, because they're using municipal water systems at times. They're using drinking water wells, water well fields, those kind of things. So any regulatory purview of those wells themselves is under NMED, not under OCD's jurisdiction.
So let's talk about that first fact pattern that you articulated. So in the event that, let's say an operator, well, let me start here. OCD's authority and interaction with the oil and gas industry, is it fair to say it's primarily focused on registered oil and gas operators?
Yes.
Okay. And so when you, in an enforcement context, when you deal with an oil and gas operator, is it common or practical for OCD to also deal with chemical manufacturers or distributors, et cetera?
Through the operators themselves, we deal with the distributors at times, the manufacturers, but it's typically through the operator that we're dealing with them, not outside the operator.
And is it your understanding that, strike that, in this fact pattern that you described where an operator may not have asked a chemical manufacturer whether PFAS was included or not, if OCD is in an enforcement posture with an operator, would that, what I'll call deniability on the part of the operator, serve as a bar or an impediment to OCD's enforcement efforts?
Whether it's legitimate or not, we've heard similar arguments from operators that they didn't knowingly use it. They didn't knowingly have these situations in enforcement actions.
Okay. And so in terms of the intentional use or non-intentional use discussion that OCD is having in this hearing, particularly with Namoga's proposal, is it fair to say that OCD feels it's appropriate under this rule to hold operators responsible for the negligent use of PFAS in completions or recompletions, for instance?
Yes. And I would phrase that as either negligent or ensuring that they're being proactive, ensuring that the fluids or the additives don't contain PFAS.
It's not a defense. It shouldn't be a defense under this rule to simply not ask your chemical manufacturer whether there's PFAS involved in your.
Correct.
Right. Now I want to distinguish that from this discussion about background, because I believe the record will reflect that there's some discussion about whether that's intentional or not. And so is it OCD's intent to hold operators under this proposed rule accountable if PFAS is used in or is introduced into a completions fluids through source water?
Source water is extremely broad.
Okay.
And for most cases, source water is going to be your produced water or your municipal water supplies, something like that. You know, the municipal water supplies are outside OCD's purview. The produced water, depending on where research is, those kind of things as it develops, we could always look at that as part of what chemicals OCD is looking for if there is a breach to that well integrity. So if you're using produced water, that may be something that we could have in those discussions with the operator to look at in that very narrow scope. So when you say source water, that can be very broad. It would be defined if there was a well integrity issue as far as what we were looking at. Again, if the Department of Health regulated water wells and they required PFAS to be notified to the operators, whether it was there and the operator knew it was there and then injected it, that may be part of that scope of investigation. But OCD doesn't regulate the water wells, municipal water supplies, those kind of things.
What about a fact pattern where an operator is drilling or completing and using fresh water? And PFAS is in the fresh water. I believe some have referred to it as a background, or it's, but you're using a fresh drinking water source, and there's PFAS in that. Should the operators be held responsible for that as a use of a banned PFAS?
I think that would be extremely difficult for the operator to do on every single instance because of those thousands of cases. They're using a municipal water, they're using a drinking water, they're using those things in their operations. They're expecting that those wells are permitted through OSE and overseen by NMED as far as permissible levels. as the expert said earlier, that some of this testing is extremely expensive. You would be asking for, again, tens of thousands of potential scenarios to be testing that background water for those scenarios. So I don't think that that would be feasible in all scenarios.
So is it your testimony that it's not feasible for OCD or the operators to do background testing of that water?
Correct.
Okay. And is it a fair characterization of OCD's position and proposal that operators should be responsible for the additives, specifically PFAS, that are used in completions and recompletions, but not PFAS in the environment for which they have no responsibility?
Correct.
Okay. I want to talk about the some kind of enforcement related questions about the PFAS ban, right? Which in OCD's proposal is currently articulated as a certification that PFAS was not used. Has OCD ever banned use of a specific substance in oil and gas development, production, refinement, or transportation prior to this petition?
No, this is the first time that I'm aware of OCD has ever taken an action to ban a chemical.
Nevertheless, would you agree that this is under OCD's past practice and statutory authority, that this is an appropriate but extraordinary proposal?
I would say it's an appropriate but extraordinary proposal.
Some examples. Was there ever a time when mercury was used in oil and gas development or production?
Yes.
How about asbestos?
Yes.
How about PCBs?
Yes.
Lead gasoline?
Yes.
To your knowledge, are any of those compounds or substances still allowed to be used in oil and gas?
Not that I'm aware of.
And was OCD and this commission responsible for banning any of the use of any of those substances?
No.
Where did those mandates come from?
I don't know it for certainty, but I believe that those actions are from agencies like the Department of Health, the EPA, those agencies.
So in all other instances where the division, where specific substances are not available for use in oil and gas, those originated outside of the Oil Conservation Division under some other authority?
Correct.
Okay. Want to ask you, do you recall Commissioner Ampoma's T0 versus T20 question earlier? I believe, if I can paraphrase, the question was, right now at T0 under OCD's definition, there are 40 to 70 compounds that would be effectively banned by the proposal. Does that ring true?
Correct, yes.
Okay. And I believe he said that at T20, some time point in the future, there may be 100 different compounds. So let's just use 70 to 100. As Deputy Director, what's your opinion enforcement discretion regarding the use of those additional 30 compounds? If there's a compound that is not prohibited under the definition today, but is prohibited under an expanded the dynamic definition in the future, based on additional scientific consensus and development, should operators be held responsible for use of that compound prior to it being effectively banned under the definition?
So I think looking at spills and spill history kind of correlates to that. There's times where the determination of whether there's a release or not is the determination of when you find the release. I think OCD is trying to be proactive in including as many substances within caution or clarification as we can, testing that we can. But as those develop, if, say, 20 years from now, we find that a chemical was used by industry that was harmful to the environment, harmful to public health, then at the time of discovery, we would be working with that company under the spill rule or under Part 30 to try to remediate that instance. As that moves forward, what OCD is looking for in this rule is to identify as much as practical at the time of release and to be involved as practical at the time of release. And it's hard to do that unless you have a testing method to test for. I think the 70 chemicals OCD is looking at testing potentially for PFAS now is an extremely large list. I understand that sounds really small when you compare it to the millions of chemicals that are out there, but are potential chemicals based on the experts. But 70 chemicals are an expansive list based on not all of them have sounds like toxicology reports on them. Not all of them can be deemed as toxic at this point. So I think even going as far as we are, we're being extremely proactive and protective based on those guidelines. And we're doing it based on what we can test for at the time of that well integrity issue.
Okay. So using one of my previous examples, like PCBs previously were allowed to be used, and we're not banned. And then spill rule, a release rule, Part 29 changed. So am I understanding you to say that under that rule, as OCD becomes more familiar, the science develops, that the testing, delineation, and remediation requirements necessarily change?
Well, and I think we could even expand it a little bit further to chlorides. Prior to the 2018 rulemaking under Part 29, chlorides weren't regulated in New Mexico. As far as releases, they had to be conditions of approval, those kind of things on releases if there was an impact. That's one of the primary constituents in produced water impacts. So the OCD adopted chloride limit in that rule, and any releases discovered today use that chloride limit, whether they happened since 2018 or whether they happened prior to 2018. They have to use that chloride limit.
So is it fair to say that as that definition develops, operators could be required to remediate for additional compounds, but would not necessarily be strike that? Would you agree that there's a difference in terms of OCD's and enforcement authority in terms of holding operators accountable and remediating contamination versus formal enforcement action and civil penalties?
I think you phrased that well. I think if an operator unknowingly uses it because it's not tested for today, and we find it in 20 years when the definitions, things catch up, we may not take an enforcement action against that operator because they didn't have the knowledge or it wasn't available to know that it was there. Now, if we find that they intentionally use it, that's something we could always go back and look at. But if it's something that they didn't have the ability to know that was there, at that time, we wouldn't be looking at taking enforcement action on that. We would be looking at taking corrective action with the operator to clean it up.
Thank you for that. Mr. Powell, I think I would like to move through, if this is still helpful to the commission, into OCD Exhibit 4, and I'll share screen and ask Mr. Powell to walk us through as I get it up. So Mr. Powell, this is OCD Exhibit number 4. It's already been admitted into the record. Is this the slide deck that you prepared describing line by line OCD's proposed changes to Wildlife Guardian's amended petition?
It is.
Okay. And I'm just going to pardon as I scroll through because they're not actually slides. could you please, I believe you have already provided the summary, so I'm going to move directly into an overview. Could you provide a quick summary for the commission of OCD's changes to 19.15.2.7?
So just to review this section, 'cause I don't want to read what everybody else can read. This section regards definitions that are used in OCD's rules. They're overall definitions, so the definitions included in these sections affect all rules in the OCD statutes.
I'm moving to page 27. Please describe for the commission the content of this slide.
So the content of this slide is OCD is moving to reject the addition of the definition of chemical and chemical disclosure list. As previously discussed, I'll hit chemical disclosure list first. OCD is not supporting that action at this time. And then OCD is requesting to remove the word chemical from the definition, primarily because it's a common industry term and it's used in several other OCD rules. And OCD wants to ensure there's no unintended scope or consequences from using that definition.
Generally speaking, as we work through the definition section, Mr. Powell, is it true that adding a specific or a PFAS specific definition to any of these proposals in part 2 could have unintended consequences of limiting the normal applicability of that same term in other sections of rule?
That's correct. And maybe I didn't address that well enough to start with. Anything in part 2 affects all of OCD's rules. So anything included in section 2, if say chemical is referenced in some other abstract rule, it would affect that use as well. There's not a PFAS specific section in OCD's rules. So that's why Wild Earth Guardians used it in section 2, and that makes sense. But as a general definition, it can have unintended consequences.
I'm going to move more quickly through these and just refer you slide by slide, and you can provide your explanation. Please describe page 28.
So 28 is downhole operations. OCD is moving to strike that because it can encompass several actions. As we discussed earlier, it can encompass tens of thousands, and defining it may inadvertently exclude some of those actions that may need to be included.
And slide 29, hydraulic fracturing treatment.
Again, and I think I touched on this one a little bit more in the slides for the NMOGA rebuttal because they left it in as well. Again, OCD is moving to strike it because it's a common industry term. I think everybody understands its common definition. But if you limit it, for example, under hydraulic fracturing, they include hydraulic fracturing fluid under pressure. Without defining what fluid is, in a common practice, some people may not define nitrogen as a fluid, even though it's commonly used in hydraulic fracturing operations.
So are you concerned that the use of that this is unnecessary definition and use of the word fluid could cause confusion?
Yeah, fluid is just one example of where those concerns come from. It's a common industry term. I think everybody that does hydraulic fracturing understands its use. So I think defining it potentially causes complications.
All right, moving on to page 30, PFAS chemicals.
So PFAS chemicals, this has been discussed extensively up till now. OCD is moving to replace this definition for several reasons. One, the main one is being able to test for what OCD regulates. OCD regulates chemicals under Part 29. They regulate chemicals under Part 30. All of those are chemicals you can test for to see if they're there, to see what we're dealing with. And they have testing methods. They're there's something that can be expected to be tested. They have clear boundaries of what you're testing for and what the potential limits are. OCD included the methods that are currently can be tested for PFAS. As you heard from the other experts, there could be thousands, if not millions, of other PFAS. Some may be toxic, some may be not. OCD wanted to make sure, because this is groundbreaking process to ban a chemical, that we don't overstep as far as what we're doing with it, and banning something that may not necessarily be toxic, that needs to be banned, and that we can test for if there is an impact. Because if somebody says, well, it may have PFAS in it, but it can't be tested for reliably, how do an operator prove that they didn't use it? How does OCD prove whether it's there or not without reliable testing?
Mr. Powell, do you believe that if this commission were to ban PFAS, regardless of its ultimate definition, that creates an expectation that OCD attempt to effectively enforce that rule provision?
I would think so. And I think that has to be taken into consideration of what we're doing and the scope of what we're looking at and how it's looked at.
I'm going to move on to slide 31, trade secret.
The trade secret, OCD's modification is simply moving it under the state statute for trade secrets. I'll go through later where OCD proposes to use trade secretly differently than NMOGA or Wild Earth Guardians, but it's to reflect the statute. So if there's a change to the statute, and I believe Wild Earth Guardians was a copy of the statute, the simplicity of stating the statute is if that's ever modified, you don't have to go to another rulemaking.
So for instance, Mr. Powell, if the legislature were to change the definition of trade secret and apply an exception for oil and gas, then that definition would automatically apply here.
Correct.
Okay. Moving on to page 32, undisclosed chemicals.
It's a strike of the use of undisclosed chemicals as a definition, as we'll go into further down the slides. OCD doesn't support the banning of undisclosed chemicals. We're building in a methodology of how to get that information if there is an impact. So it's just removing that definition because by OCD striking it later on, it's unnecessary here.
Page 33, well site.
So this is another common term that's used in the oil field. Limiting it may limit some of the enforceabilities because well site may be different for OCD depending on impacts to the surface, whether it's in an approved well pad, whether it's outside the approved well pad, whether this includes the areas that are reclaimed or not reclaimed. It has other potential impacts.
So OCD's use and understanding of well site might actually be more broad than Wild Earth Guardian's proposal?
I don't think OCD uses necessarily well site as far as in some of the rules, how they're directly affected, but it may indirectly affect those.
Could you please describe, summarize OCD's proposed changes on slide 34? Like basically, what does part 7 relate to?
Oh, let me look. Part 7 is the forms rule. It's the OCD's rules that goes through different form types, and individual forms are listed in there, and requirements of the operators for those forms are listed, such as completion reports, completion sundries, those type of things. So OCD is moving to remove the undisclosed chemicals provisions in that. We're supporting the certification that no PFAS was used. That's mainly the changes that OCD is looking for.
Great. Do we have time to, should probably cut
Yes, thank you very much, Mr. Tremaine. I stay right where you are. Folks on the platform, we're going to go just a few more minutes with the technical witness we have on the stand. I will invite your public comment within the next 10 minutes. But I want to get to a good stopping point with Mr. Powell. Please hang in there with us.
It's fun. All right, Mr. Powell, I think that, well, let's just start here with the chemical disclosure slide on page 35.
So I think it's probably helpful just to look at the OCD modifications for this of what OCD is requesting change. It's the strike of the chemical disclosure list. It's clarifying that it's applicable to added chemicals that were added to the fluid used. So it's chemicals that the operator should be working with their chemical companies to identify and ensure are PFAS free. Those are the main changes, the theme of the changes in that section.
Great. And the slide about 36.
OCD agreed with that change.
All right. And on 37.
So 37, I think the clarification to this area, OCD proposed to keep this data at 90 days instead of changing it to 60 days, just from a functionality standpoint and to ensure clarity on this one. So the 90 days is from the date of the actual completion itself, not from when the paperwork's filed. So it's not that OCD keeps the paperwork confidential for 90 days. The paperwork is delivered to the OCD on the 105, I believe, at 45 days or 103 at 30 days. So you're looking at, say, the 45 days, you would only have a confidential period for 15 days. Functionally, with OCD processing, OCD may not even process that at that time. That's a quick turnaround, looking at 2 weeks. Also, to evaluate that if it's going to hearing to see if it could be confidential or not, whether it should go to hearing, that evaluation takes time.
Could you please address the shall versus may?
So the shall versus may, OCD believes is important as the data may not be requested for the hearing, or it may be deemed additional confidentiality through the Trade Secret Act, those kind of things. So depending on where that lands, the may fits that best because it may not be included in the hearing, depending on those evaluations.
And slide 38, OCD also agrees with this change?
Yes.
All right, please describe slide page 39.
Slide 39, just in principle, that's not something we typically put in the rules as far as each individual form. It's something OCD does as far as keep those records indefinitely. That's all part of the State Records Retention Act and rules, and that OCD has to abide by. So including things as far as retention there, if state records made a change, which they're the regulatory body over state records, may conflict. So we're just asking for that removal, even though functionally we do keep that.
Okay. Madam Hearing Examiner, we're about to move on to kind of some more interesting, more substantive stuff in part 14.
It's all interesting and substantive, Mr. Tremaine.